A warm good morning. Basics of Python programming. Dr. L. Pallavi is our speaker today for morning session. Dr. L. Pallavi is Associate Professor of Computer Science and Engineering. In the department of in CSC department of BBRIT, Narsapur. She received her BTech and MTech degrees in CSC from the JNTU in 2008 and 12. And she received a PhD degree in Computer Science and Engineering from Yale University. She has been in teaching for more than 13 years. Her current research interests are in the field of cloud computing, IoT, artificial intelligence, machine learning, and data science, etc. Based on her research work, she has published more than 20 research papers in various international journals and conferences. She has completed one consultancy project. She is the reviewer of many international journals. She is the author of one book chapter published by Springer Publications. She is the Department Training and Placement Dean for UG students. She is the mentor for Infosys, EPAM, Virtusa, Pega, and TCS selected students. She also conducted several coding contest programs in BBRIT. She has given 5 guest lecturers in various engineering colleges and universities for UG and PG students and faculty. Before moving ahead, I request all the participants kindly mute your mic and camera. And if you have any question during presentation, feel free to write in chat box. Your active participation is important throughout the session. Without taking much time, I would like to invite Dr. L. Pallavi to start the session. You can start, madam. Over to you, madam. Thank you. Madam.
Ma'am, we are not getting your voice. Ma'am, we are not getting your voice, ma'am. Ma'am, are you with us? Ma'am, we are not getting your voice, ma'am.
No audio, no video, madam.
Is I'm okay now?
Yes, ma'am.
Yes, madam.
Yes, ma'am.
Yes, ma'am.
Voice deletion. Ma'am, you are co-host now. You can share your screen, ma'am.
Is it okay? ఇప్పుడు ఓకేనా? నా వాయిస్ క్లియర్ గా ఉందా? ఓకే ఫైన్. నేను ఇందాక నుంచి అదే. ఓకే ఫైన్ దెన్. So now coming to here. So coming to the first one, like programming, we are learning for the programming purpose is like to calculate the functions. Okay, for security purpose or for developing any kind of an applications, we are learning the programming. Now, first initially, I think everyone knows the basics of C programming. Can anyone say what is the structure of C programming? C language programming, anyone, whatever you know, just put it on chat or else just unmute yourself and say the answer. Anyone, what is the structure of C programming? What is the purpose? Anyone? Okay, fine. So now coming to here, I'll write one thing, two types of a code, okay, in C language and in the Java. Then you can understand what is the purpose of learning the Python and how it will be easiest for the users to develop an applications. Now, see the thing. I think you people can see my entire screen, right? Hello, just give me an answer. Can you see my entire screen like notepad and PPT?
Yes, ma'am.
Yeah, okay, fine. Thank you, ma'am. So now I'll write the thing, first one. So when you go for the structure of C program, the first step will follow like documentation section. Okay, in this documentation section, we'll mention like what is our program we are writing here. Okay, it's like a document type indication. So for example, I can give the statement like this program is used to display hi. So if I want to display such kind of a message, so those kind of a thing I'll written in the documentation section. Now, this documentation section will not be executed. This is only for the user's sake. Each and every line indication, what is the purpose of the line, the statement. Okay, so those are the things we'll call it as like documentation section. So in this documentation section, when we're using the programming, we'll use a concept like comments. In C language, we had only the two types of comments. Okay, one is like single line comment, that is like single line comment. Other one is like multi-line comment. So in single line, if you want to describe a single line statement like, so then we'll use a concept like single line comment. And this is the symbol we call it as like forward slash. Okay, two double slashes, we'll spell it as like forward slash. So in this statement, we'll write like, if you want to mention any kind of a line, so then we'll use the single line comment. Then if you want to make like in a documentation, so if you like when you're after writing your program, you want to give the complete documentation, each and every line, then we'll use a concept like multi-line comment also. So the multi-line is like forward slash star, and you can define anything and slash star. This is the syntax. So as per the structure of C program, in the first step, we'll write documentation section. And in the second step, we'll mention like preprocessor section. So what is a preprocessor? For example, I'm a programmer. If I want to use the previous library functions into my program, if I want to include, then I'll use a concept like preprocessor section. Just remember, okay, here the preprocessor is nothing but as it will be starts with the symbol of hash. So in this preprocessor, we had two categories. One is like include section. Okay, that is like include section, or else I can spell it as like link section. So what is the purpose of this include or link? Yeah.
Sorry for the interruption, ma'am. Is your intention to show the notepad also?
Yeah, yes.
It's not visible, ma'am.
I have shared the entire screen now.
No, it's I mean, your PPT is only visible. It's showing like basics of Python programming.
Yeah, yes, now it's okay.
Yeah, it's okay, ma'am.
Okay, fine. Thank you.
Thank you, ma'am.
Now, so in this preprocessor, you're defining like all the libraries. If you want to include into your program, then we are using this second section like preprocessor section. Now, so, and the second category is like definition section, or else we can spell it as like macros. So the second category is like definition, or else we can spell it as like macro substitution section. So if you want to divide the entire program into small individual parts, And that individual parts, you have to know that debugging easier. If you want to make such kind of things easily into your program, then I'll use a concept like definition section. Okay, so these are the two categories we had under the pre-process section. Now, why I'm saying the structure of C program is that if I say the structure of C program and structure of Java, then you can understand why we are going for the Python programming and why it will be used in the coming the market boom. Okay, so that's the sake I'm just showing the syntax. What is the differences between C, Java, and Python? Later, I'll go to the Python programming in deeply. Okay, and now come to the third step. According to the structure of C program, we had like global declaration section. So what is the purpose of global? For example, I'm the team leader. Okay, I had the members like 5 or 4 members. If I'm using any kind of a data, that data has to be showed to entire my team members. Okay, then I'll define such kind of a data as a global. So in this global, I can define the variables as well as I can define the functions also. So this is the global declaration section part. Okay, now come to the fourth category that is known as, so we'll say that the program will be starts from something indication part like main like that. So coming to the structure of C programming, every program will start the execution from the compiler will start the execution from main section onwards. Okay, so I can take it as like main. So now coming to here, if I want to understand the main, whatever the thing I'm returning under the C programming, everything it will be treated as like functions. So if I'm using like a variables or data types, okay, or else user defined things, any kind of a part, small part, each and every term, I'll spell it as like C is a completely function oriented programming, or else I can spell it as like procedure oriented programming. Okay, now when I'm discussing about the functions, just in real time, if you take like a practical example, it's a function. One of my friend invited me like a function like birthday function. So we had generally 4 types of human beings nature. Okay, so my friend has invited me to the function. So what I'll do, I'll take some kind of a gift. Okay, my friend is one top of the richest person. So he'll also give the written gift to me. So that means giving and taking policy. So in functions, coming to our practical life, when you're going for the programming, the function syntax is like, first thing, return data type. Next, name of the function. Here the function name is like, it is fixed. That is like main. So if I want to define my own function, I can define like Pallavi or else MLRT like that. So this is the indication like name of the function. So it's a standard function here. So I'm using like the function name like main. Next. So if I want to know that, I want to pick, this is a function. Okay, this is an array. So how can I identify those things? Okay, that is like delimiters. I'll spell it as those concepts like delimiters. Delimiters are nothing but as, so it's like it doesn't perform any kind of an actions. It gives only the meaning. That is known as delimiters. So if I use like parentheses, this is nothing but as a function in my programming language. Whether I'm using Java or Python or C, C++, anything. So parentheses nothing but as a function. Now, if I use like square brackets, I'll spell it as like it is an arrays. Okay, if I use like curly brace, then I'll spell it as like it's a block of statements. This is the fixed. Okay, so now coming to here, when I'm saying like a function, I'm using the concept like parentheses. Now, in this parentheses, I'll spell it as like parameters, or else I can use like arguments. So this is the exact syntax of the function. Now, so return data type. That means if I executed my function, it is not necessary to return the values to operating system or to some other function. Okay, now that is the return data type. Here I can mention like any kind of a data types. That is depends upon our requirement. Now, when I say like a main function, I'm not taking any kind of parameters from the operating system or else from other functions. So if I'm taking anything, I need to mention within the parentheses. When I'm mentioning those things, I'll spell it as like it is a parameters or arguments. Now we are saying that execution will start from main. Yes, the indication how This is the 4.1 syntax, that is like open curly brace. Here the execution will be started. Now in 4.3 syntax, 4.2, you can define here local variable section, local variable declaration section. And coming to the 4.3, you can define here like executable statements. And now 4.4, the close of the main. So these are the main, just the structure of C program syntax. Now, so if you want to write any kind of a programming like, so if you want to implement like factorial or GCD, okay, or addition of two numbers. So if you want to implement all those things in the single main function, okay, if any kind of a bug raises, so it is impossible to find out the time-taking process, okay, to find out the bug here. So to overcome that drawback, what we are doing here is that we are using the user, we are creating our own functions here. Let's take an example of birthday. So one of my friend is having the birthday. He is only the taking care of the responsibility of receiving the guest, okay, and dinner part and snacks part, gifts part, everything. So if he is taken overburden, so what will happen here? He is not interested to cut the cake also. So he want to reduce that. What will take? He will take the give the responsibility to his friends. So then the burden will be decreases. Like that only in the main function, if you define everything, so it will make like a clumsy. If you want to find a bug also, it will take time. So if you want to become a good programmer, okay, we need to reduce the time first of all. So for that sake, we are creating the concept like user defined functions. So that is the fifth category here, like user defined. So the syntax for user defined is like same thing, return data type. So whatever the function name you want to define, you can define. Okay, but remember the same function cannot be repeated in the program. If you repeat like that, then you can't understand. As a beginner, you can't understand what is going on here. So just try to understand. The main is a standard function and it is a user defined function. So the execution starts from the main itself. If you want to create your own functions, those functions have to be created under the fifth point, according to the structure of C program. So now this is like user defined functions. So when I say it's a function, the delimiter is like open and close parentheses. And the same thing you can define like here, parameters or arguments. Okay, here return data type. RDT stands for return data type. Okay, and now coming to here, 5.1, you can define that is the indication, the execution starts here. Next, 5.2, you can define the local variable section. So this is the structure of C program. So now coming to here. So here we define in the documentation and the preprocessor and global declaration. And here the fourth part is like main. And the fifth, we are defining the user defined function part. So we are saying that whatever the thing, okay, if you want to develop any kind of an application, you can write the code using the C language also. Now, but coming to here, what is the drawback under the C? So let's see here in the main section. So if you're defining anything, we can't rewrite the code here. Okay, we can't provide the security. So for security purpose, we need one language. So what is that language we are going here? Like object-oriented programming concept. So object-oriented programming concept has nothing but as behind everything, the code will be like secured. Okay, and we can protect our data. And here the data will be hidden from unauthorized persons also. So these kind of features are available under the object-oriented programming. And here, everything will be treated as like an object. So object will be like fully protected. But coming to here, C programming, everything will be treated as like functions only. Okay, so in these functions, we can't provide any security. So that is a drawback under the C programming language. So that's why every person will say like the C is a completely function oriented programming, or else they will say like procedure oriented programming. Coming to here, procedure and function is totally different. But for your sake, just remember that the C is a completely function-oriented programming. Now, so what is the concept we are saying here? Like the execution starts from here, like main. Now, coming to here, I need to provide security. I'm saying here, I need to build more applications within a less span of time. So for that sake, I'm going for the concept like object-oriented programming. Now let's see here. So before going to here, if you write the program, okay, what we'll do, like I'm just writing the WAP is nothing but write a program. So this is the documentation part. I'm just giving the example. So at the top, I have given the syntax. At the bottom, I'm writing the simple program. Then you can understand here. Next, the first part, documentation. Yes, I written the documentation part. And the second part, preprocessor. So here I'm defining like hash include stdio. Why? Because everything will be like the compiler will translate our high level language to machine understandable code. So for that sake, I need the predefined libraries into my program. So that's why I'm including the header files into my program here. Next, I'm not using any definition section. I'm not using any global declaration here. So now directly I'm going to the fourth part, that is like main. So I'm not receiving any values from the operating system, as well as I'm not returning any values to the operating system. For that sake, here I'm mentioning the concept like void. So void prefers like does not return any value. Okay, that means it is an indication to the compiler. Now void. So this is nothing but as a return data type and name of the function and the parameters. And now here, I'm just, my program intention is that just to print hi. So here, for printing, we are using the output statement like printf. Okay, so you can see like a print is an output and f is a functionality. So what is a functionality it has to perform here? Like within the quotations, whatever the written, just it has to display on the screen itself. And we are saying that for the compiler purpose, here it's a command to the, in your language like microcontrollers or microprocessors, when you're doing anything, so the statements will split as. So the statement, every statement ends with semicolon. Like that in the C, we are using this kind of a statement. Next, end of your main. This is a simple program using C language. So here the execution will start from here and compiler this one. Now, after writing the program, what was the next step will follow generally? Saving the program. For saving purpose, here we are using the concept like F2, the shortcut key. So I'm using like p1.c. This is my file programming. Okay, next after saving, I'm going for compiling. So what is the compiling process will happen here? P1 dot get like obj, object file. Next, after creating the object file, then it will go for the executing, or else I can spell it as like running. So what will happen here? The next step, p1.exe file. Okay, so that means it is a completely executable code in the format of zeros and ones. Is it? By seeing this kind of a statement, we can say the C is a completely platform dependent language. It totally depends upon the particular hardware of the system. Okay, these are the simple steps. Now, what is my intention is that now in one system, I executed this program. I'm going for try to execute the same program in another system. Okay, so whatever I did the compiling, the same program I want to run into the another system. So what will happen here? The hardware is totally different. Okay, take it as an example. Here I'm using Intel. There I'm using like Motorola. Here I'm installed Windows. There I install like Linux. So if I want to execute this same code into that operating system, it can't be embedded. So what? Because the hardware is completely totally different here, and this hardware depends upon this Intel. So it's like the concept we'll call it as like platform dependent. So I need the platform independent. Why? Because I want to implement my code, my application in different areas. So I want to perform like the concept like ORA. ORA stands for write once, run anywhere. Okay, I want to perform these things. So for that sake, we are going for the concept like object-oriented programming. Okay, the C is nothing but is a procedure-oriented programming. Now, coming to the object-oriented programming. So in this object-oriented programming, the syntax will be like, just I'm showing the simple syntax. Okay, so first one, here you can go for the concept like, same thing, documentation. And the second part we'll call it as like package section. For every object-oriented programming, this is the syntax we'll follow here. And the third part, we'll call it as like interface section. And next one, fourth one, class section. The fifth one, class with main section. So these are the 5 steps we'll follow for the object-oriented programming concept. Now, how we'll write the same programs? Let's see the same program if I want to return into the object-oriented programming. So generally in the object-oriented programming, the first language came to the market like Smalltalk, C++, then Java, and next Python. Okay, now, so for the documentation here also same thing I'm using like comment. So write a program to print hi. So, and coming to the package section, there I'm using like hash include stdio.h. But coming to here, I'm just writing the code in the Java here. So import, in the place of include, I'm using the import here. So there I'm importing, including like std, that is like standard input output dot header file. Here, same thing, input and output packages I want to input into my program. For that sake, I'm using java.io.start. Next, there I use like global declaration and main section user defined. Here in the third, I'm a beginner. I'm directly going for the class with main section. So what I'm writing here, if I want to perform like write once, run anywhere. So here I'm using the concept of class and my program name is P1 opening curly brace. So every programming language is called as execution starts from main we are saying here. So here I'm using the concept like public. That means my code has to be run in different operating systems. Okay, next, static. So if I want to execute the class, I need to include like the concept of object. So without creating an object, my class has to be executed. For that sake, I'm using the keyword like static. Next, as well as the syntax of function, that is like void, no return data type, and function name main. Next, and here the parameters. In object-oriented programming, everything, the reading part of the input will be read from the command prompt itself. So whatever the data you entered into the command prompt, it will treat it as like string. So for that sake, I'm taking like string. So string is a class here. How can we identify it as a class? Why? Because the starting letter of anything starts with capital letter. Then I can say it is a class. Now, the variable name, args. Next, here in the place of printf, here I'm using like SOP, that is like system. Okay, out. System is a class, out is an object. Dot, the method print. Okay, here I cannot use like spaces also. For your understanding, I just given here print what is like hi. Next, close the main section and close the class, that is like P1. This is the same program what we return in the C language. We return here the programming using Java. So now coming to here, for saving purpose, we are using concept like p1.java. Now for compiling, here, what will happen is that if you compile this code, it will create a code like class. Here in the class, everything will be in the code in the format of bytecode. We know that mnemonic, we are like operational code and operand syntax. Okay, so if you give like a plus b here, what is the mnemonic? Will write like add a comma b. Same thing, that kind of an instructions will spell it as here like bytecode. So So bytecode. Next, we are going for executing. So there we'll get like exe file. This is the syntax. So what is the differences between in the C code and the Java language here is like, in compiling of a C programming, what we are doing like object file will be created. But here the bytecode will be created. If I take this bytecode and if I execute in different operating systems, the bytecode contains only the instruction part. So if my hardware is depends like 8-bit or 16-bit or 32-bit, the code will embedded here and it will be executed. Okay, so that means the Java or else object-oriented programming, the concept will call it as like ORA. Write once, write in the one operating system, run in multi operating systems. That is the bytecode part. So now coming here, what is a bytecode? How will the system can recognize here? Like here we are using the concept like JVM. That is like Java Virtual Machine. Okay, so Java Virtual Machine is one kind of a language code. It will be written in using C language. Okay, so what is the role of JVM is that it will take the input of bytecode and it will generate the exe file. Okay, so if we want the generate the exe file, what is the translator the JVM is using? Inside in the JVM, we had one kind of a translator like interpreter plus just-in-time compiler. So these are the two types of translators that are embedded in the JVM. So to speed up the process of execution. So this is the concept of object-oriented programming. Okay, how it will provide the security. So the security will be provided based on the class. Okay, next, coming to here, it will treated as everything as like an object. Yes, why? Because it is one of the principle of object-oriented programming. And the third one, every object-oriented programming language uses two types of translators. One is like compiler, other one is like interpreter plus just-in-time compiler. So these are the techniques. So how we can say it's a platform independent. Okay, how it is taking. This is the based upon this concept. Now, coming to the differences between the C and Java and why Python is king. Now coming here. In C, we are saying like function-oriented purpose, we are using the C language, we are saying, okay, for the object-oriented purpose, we need Java language. But as a programmer needs both kind of concepts like function-oriented plus object-oriented programming. Then what is the language will be supported here? And it has to be like simple and easy to understand. Like doesn't follow like a big syntaxes here, okay, and libraries and everything. So without that, easy to learn. That means interpreted code the programmer needs. For that sake, we are going for the concept programming language called Python. If I want to execute the same code in Python, what I'll write the statement like here, like print hi. So instead of following these many lines in Java, okay, as well as in C, but in Python, the same program can be written in a single line. Okay, here we are not using like a documentation. Then what is the purpose? How the other unknown user can understand this code? Here, line to line, here we need to mention like the comments, like in the comments, we are using the // Here we are using hash. So just here like it is used to print output on the screen something. So this is the line to line explanation we are giving. This is the comment, Python comment. Okay, so now if the user wants to develop like function oriented, he can use a Python. If the user wants the concept of object oriented, then Python will be supported. But here, how can you build like ORA principle using Python? In Python, if I want to build like ORA, we are using the concept of PVM, Python virtual machine. So by taking the principle of PVM, okay, the PVM can supports the object-oriented programming successfully to the user. So these are the simple basic background history why we are going for the Python. So till here, any queries you people have? Is it okay? I'm not going to the deep here. So just
Hello?
I've given, yeah.
There are cross compilers also there, no, madam? Any effects
Yeah.
will be there?
Yes, sir.
So you're having architecture independent, no? Actually, you're having cross compilers.
Cross compilers we had, and in Python we had different types of flavors like C Python and J Python. By using those concepts, we can install the Python, those compilers. Go to the website like python.org. You can download the J Python and C Python. So depends upon your requirement, you can run the code. The compilers.
There are different versions are there, no, madam? Python, which is a better one?
Latest only, sir. Python presently, I installed this software like Python 3.9.
So that is why the different versions are there. That is only for architecture independent, or
Architecture and the data types.
okay.
Initially, the
different
keywords are like
versions
26.
are.
Yes, sir.
Oh, okay.
Initially, like if I want to read just I'm giving the example, older versions, if I want to read the data from the keyboard, I'll use like raw input. But coming to the latest compilers, so I'm directly using like input. So differences are there and the data types are also increased. Okay, if I want to maintain like explanation form data type, then directly I can use like format. So these are the features are there under the Python 3.9. And you can install the libraries also. If you want to use like a data visualization, okay, you can directly import the libraries instead of connecting everything steps follows. Okay, directly I'll show that one, how to install the libraries also. So till up to here, is it okay now? Shall we go to the concept version? Why we are using the Python? Okay, how the Python syntaxes is there and the differences between C, Java, and Python. Okay, now I'll go for the less theoretical part, more programming. Okay, now coming to see the concept of the Python scientists like Godio von Ransom. Okay, by the name, we have to, when we are learning any kind of a language, we have to know the history a little bit, like why the Python came into the main market in 1991. So the scientist is watching the continuously, like he likes this circus show, Monty Circus. Okay, so by seeing that, he liked that kind of a Python snakes. So he implemented the logos here. This is a Monty Circus logo show. So he drive the logo here and implemented. So why we are going here like both implementations, general purpose programming and system purpose programming. If I want to implement, so I'm choosing the Python. So there is no like, if I know the C only, then I can understand Python, not like that. Everyone can understand easily. If you sit hardly one day, the Python course will be completed easily for you. So now, what are the futures? We are saying that in the procedure-oriented programming, we are picking like Pascal and C language. In object-oriented programming, we are picking like Smalltalk, C++, Java, and Python. Okay, and these are the exact features of Python. So it's a simple, yes, easy to understand. Okay, no proper syntax. The syntax is like here only we have to follow like indentation. There in the C and Java, we are using like curly braces, but in Python, we are using like indentation. Okay, so when you're going for the Python software, okay, window, directly the indentation will be blink. So if I'm not using the like that, if I'm going through Notepad, then I need to give the indentation format here. I'll show that one. Next, it's an open source. Yes, there is no like licensed version. Okay, you can directly visit the python.org website and you can download any kind of a version based upon your requirement. First thing, if you want to implement like frameworks, okay, web applications, UI applications, then better to choose Python 3.9. It is easy to use. And next, we are saying we are creating lot of variables. Okay, when we need any kind of a programming, so variables occupies a memory a lot. So forgetting the deletion of memory. So there, what we had the PVM, that is Python virtual machine. It will check after execution of each program. It will check that any kind of like unused memory. If it is then just it will gather out. Okay, that kind of a gathering. It's called as like garbage collection. So garbage collection is that storing of unused variables data. So if you need any extra memory also, we can use it. If you're not using, but the variable is like saved into the memory there. So instead of that, it will produce like garbage collection. It's like a traffic policeman. Okay, and next, if I want to convert from one data type to another data type, then I can strongly typed conversions I can use here under the Python. Okay, so converting from one data type to another data type, the concept will call it as like type conversion. So if I want to do, I can do like a strongly, that is like robust. And we are saying like portable. So same thing, platform independent. How? Based upon like Aura principle plus PVM. Next, object oriented. So if you want to build like interfaces, okay, multi-threading applications, then we'll go for the object oriented. And interpreter we are saying here. Generally, it's like the shell mode is an interpreter, the Python. Okay, so in this interpreter, so how the code will be executed without using the Python compiler also, how the code will be interpreted. Okay, now dynamic, yes, during the running time of the program also, I can create the memory for my application as well as for my variables. So it's a dynamic, extensible. The versions, for example, Python 2.7 plus adding new features. So we can develop like Python 3.9, just an example I'm saying here. Okay, if you take like input and output statements or operators, etc. Next, embeddable. So it's a simple like in Python also, I can write the C code, okay, like printf, scanf like that. Same thing, I can write the Java code also. For why is it necessary to write like depends on application. So if my application requirement needs some specific format, or else I need some specific format, the output has to be displayed. At that time, I can embed the concepts of the C or else Java. Next, extensive, we are saying that same thing, and the easy maintenance, security, multi-thread. These are the features. In these features, now we are implementing 5 different types of concepts here. I'll say that one. Okay, these are basic features. Next, where the Python will be used. Generally, for the GUI applications, we need 3 types of architectures. First level is like easy to understand, I'm saying here. So these 3 architectures, that is like 3-tier architectures, we'll spell it as like, we can take it as like a business view, okay, presentation or view purpose. So how you can implement easily in Python, that is like GUI application. So we had different types of frameworks also, like Danjo, Flask, etc. So based upon that, the features, I can develop the simple GUI application easily compared to Java. Okay, but in Java, I need to follow the certain steps, connectivity, backend and front-end connectivity. That is a one procedure. And for the front view, I need to write the code. And next one, like I did the servlet, server side. So if I want to implement this like time-taking process, I need simple thing. Already libraries are there. I have logic. I need to implement just logic. So if I implement, it will hardly take half an hour for me. But the same web application, if I want to develop using Java, it will take like 2 hours of time. So easy to understand for me. If you take like data analytics now, okay, and machine learning, and if you in the machine learning, I had an algorithm I need to implement. If I go for Java, it will take like 50 lines of code. I need only 15 or 5 lines. I can go for the Python. Why? Because a lot of libraries are available in the market now. For same for the data analytics also. Okay, next. So these are the simple limitations. So I'll say that one when I'm writing the program. Okay, previously also you can see the observations like the C programming code, Java and Python here. So now I'll explain that one. And the applications of Python, I'm just focusing on the web applications here. So nowadays we had for the students, for our faculties also, we had like web development internships are available. Okay, so using the Python, it will be easy to develop. Okay, now most of the companies also preferring this one. Now we are saying like GUI based desktop applications, like it's a standard applications also we can build using Python easily. Okay, how can we build? The based on the libraries, the requirements is needed for us. Okay, why? Because in Python we had different types of flavors and the libraries also. So the libraries word here we can spell it as like batteries of Python. Okay, example I'm saying like batteries of Python is like NumPy, skitlearn, matplotlib, pandas, etc. Okay, so it based upon our requirement purpose, we are installing those libraries and we'll building. So 2 lines of 3 lines of code, that's it. Our program will be completed or our application will be completed. Okay, so but what I suggest is that if I want to become like smart coder, then I can prefer like Python. If I'm a beginner, I want to learn the logical thinking as well as coding easily. So then I have to do like hard coding. Okay, that is important for us. So if you write the code in hard coding purpose, we can understand the scenario and the logic will be striped immediately. So if you go with smart coding, the developer had developed the different types of libraries. We are importing just, but we don't know what is the purpose of that library, how it will be used, and what are the functions are available. We are not focusing on that. Okay, so but depends upon the domain purpose we are choosing. So my suggestion is that go for hard coding, not for soft coding. Okay, now coming to the part, so I'll directly, these are the different applications, and now I'm just going for the programming part. So if I want to execute my Python program, I'll just show 3 types of variations. Just I install the concept of python.org web. So go to the website of python.org website. Okay, in that download the latest version of Python. So I already installed my Python version like Python 3.9. So you can see here. So this is a Python 3.9 version. So after installing, we have, if I want to execute my Python program, okay, we have 3 ways. One is like idle GUI part. Okay, other one is like command prompt. Other one is system prompt. These are the 3 ways to execute the Python program. So now first thing I'll show like idle part, how to execute. So if I choose like idle, say idle Python 3.9. So this is a GUI concept. Why I'm saying like idle GUI? So it is like, it's a graphical user interface part. Okay, whatever is written here, you can see. So this is the interpreter. Okay, what are the arrows we have like interpreter prompt. So this is like directly, we call it as like on user calculation purpose programming. Okay, next, this is the idle window. This is one way. Now, if I want to write a big programs, okay, this is not the way for me to understand. So what is the second part? I'll go for like in idle window, I had like new file. So I'll go that. So my notepad, okay, is open. Here I'll type like the command or else any kind of a statement. After writing, next I'll go for saving part. Now you can see the path here where my default for any system, okay, it will be stored in the app data local programs Python 3.9 version. So here exactly it has to be stored my program in the .py version. So that's why I'm giving like p1.py. Okay, now if I want to execute this one directly here in the run, I can go for run module or Python shell. Okay, Python shell I can view, or else if you want to see the output, okay, then directly I'll go for run module. So this is the one way. Second way, first one is like idle. Next one, going for the new file. That is like, you can say like a file notepad. So like that, you can type the code and you can execute. These are the under the idle part itself. Now, if I want to execute, if I want to read the data from the command prompt, how? Then what is the thing like? So here, I'll type like command. Now, here I'll create one directory for my sake. So that is like MLRIT. Now, I'll go for this directory. If I want to, in C drive, I created this directory. So we can see here, MLRIT. So the directory has been created. That means my folder has been created. So cd MLRIT. Now, after going this, now here I'll type like notepad. So here I'll type simple command statement like hi. So for saving, so MLRIT we are saying here. So C drive. Here I'll save the code like p1.py. Now close this. So if I want to execute, if you see that in MLRIT, my p1.py program has been stored. So it is a file program. So file. If it is a directory, it will show us like directory for us. Now, if I want to execute this one, Python, okay, p1.py. So it is saying that Python is not ready. So I need to set the path. So when I'm installing the software, I need to set the path in the control panel itself. If I didn't set like that, what can I do? Here I can type the command like set path equals to. So you can see here, C users/program. Okay, this is our path. Python 3.9 has been stored under the C drive user CSC. This is the entire path. I'm just copying this one. Okay, here itself. So I didn't just what I'll do is that. It does not been stored here. So next enter after setting, just I'm copying the path here. Now Python 3.5. So this is a command prompt of executing the program. That means where it will be this kind of a concept will be used for us in programming is like if you want to develop like front end or applications or database applications, simple standard applications like student database using Python. At that time, this kind of a prompt of executing is useful for us. Okay, this is one way. Now, in Python software only, we had a third way like Python command prompt. We can go for here. See, this is idle window. First one is like idle GUI, and this is a command prompt of Python. So directly. So you can observe this is the Python and this software. Just see the Windows part. This is a graphical user, and this is a command line. Okay, here also just I can give like print hi. Okay, so in any kind of anything, whatever the version you are downloaded here, okay, we have 3 ways to execute a Python program. Is it okay? And whenever the you're not coming like an internal external command error, just you need to set the path itself. That's it. Fine. Till up to here, any doubts? Just the writing and executing part of a Python program. Is it okay?
The first one is idlement. What are the another two?
Another is like Python command prompt, and the next one, last one is this one is like Python system prompt. This is system prompt, madam.
Thank you, ma'am.
Okay. Fine. Now we go for the next part directly here. So generally for any kind of an thing doing the program, we need some kind of a data types. So here we had different types of data types. So here only I'm defining dt1.py. Okay. So when I set the path, then the now notepad will not be work for me here. So what I'll do here is that just now. Okay. So this is like I'm giving the comments. So first one, if you have any kind of data types, we have generally 4 different types of data types. First one is like integer data types, second one floating point, and the third one string data type, and fourth one, so I'll write here, numeric data types. So here I'm using like integer part and floating point data types. And the second one, I like string data type. In this string data type, I can use like in a character, a string methods also. And the third one, I'll use like Boolean data type. And the fourth one, generally, these kind of data types will spell it as like Python data structures also. Okay, So Python data structures are nothing but the data types here like predefined. So what the thing here like list, and next we can use like tuple, sets, dictionaries. So these are all Python data structure will split as, but these are nothing but as an advanced data types also. Okay, now coming to the numeric data type. Generally, if I want to define like a equals to 10, when I define like this a equals to 10. Okay, so I know that based upon the RHS, whatever the value we define, okay, that will be stored in the LHS part. So by Python interpreter, what will be understood like it's an interpreter. So it can understand that 10 is nothing but as an integer part. So it automatically stored here. So it can define that it's not necessary to define like int a equals to 10 in any kind of a programming language. Will define like int a equals to 10, okay, or else long int or short int, etc. So here there is no need to define. It's like an interpreter, the scripting type language. Okay, so when I define this one, I can use like if I want to know what is the data type, so I can use like type of a. So what is the purpose of this method is like, okay, so generally in Python, just remember when I'm using like parentheses, I'll say like functions in C programming or Java programming. But in Python, the method is different, function is different. Okay, function is nothing but as an whatever the data you return outside the class, that is nothing but as a function. If you return this kind of a statement inside the class, then we'll spell it as like method. Okay, and the module is different, but most of all the people will say like method, function, module is same. Okay, they are totally different. Okay, three are different in Python. Just remember this point. Method is different, function is different, module is different. Okay, all three are not same. Now, so this is a predefined method and just want to know what is the type of data type it is being using. So here I can mention like print of this one. If I return this statement, okay, so what is the output I'll get here? Just see here. So these are the lines I written here. Now I'm using in Python, we had one type of a third type of a comment. Generally, single line comment is there, multi-line comment, documentation comment is available under the Python. So how to import that? So here, when I given like 3 quotes and here 3. So this part I'll call it as like documentation comment. Okay, now this is the 2 lines of code I written here. I'm just saving here under the mlrit.py. Now, when I'm going for the execution part, so you can see like, so this is a code I written here. So type is nothing but is a predefined method. It will display that what is the RHS value of A has been stored. I know that it isn't a 10 is an integer. So it is displays the type will display the what is the method of a variable value has been occupied here. Okay, like that I can use like same thing. So we had like a Boolean part. So true or false I'm defining here. So here I'm defining like Sai. You can say like T. Character I given. So general basic data types I given here. So 1 plus some 3 I given. Just so these are the things I given here. I'm just copying. So 3 I given. So 1 second. I this the syntax. 1 second. So here now coming to here, I didn't use a complex data type. I'll use it now. See, the first one of the RHS I had taken like integer, so it is displayed like class int. Next, coming to the statement like I have given the floating point value. So this is a part. So it has displayed like float. Now, if I use like true, in Boolean, we had only the two constant values. One is like true, other one is like false. Okay. So if I want to mention like false, I need to take it as like F is a capital. It's a predefined standard words here. Okay. And true or false are the keywords also in Python. So now I have taken like in a string part, more than one character enclosed with single quotation. Generally in C language, if I want to define, if I define like in a characters like this, so this is nothing but characters. I can't say it is a string. But in Python, if I mention anything in a single quotation of a symbol, alphabet, or any kind of digits, so it will treat it as like only string part only. Okay. Now coming to here. But in C, if I define like this, it will treat it as like character. Same thing in Java also. But if I want to mention like in a string, then I'll use like double quotations. Okay, this is the syntax of C language. Coming to here, Python, I can use like single quotation, okay, like Sai, or else I can define like double quotations, or else I can define like triple quotations also. So this is a string part. Entire thing, it will treat as string only. If I define, okay, for example, if I define like single quotation like this, or else like this, or else triple quotations, it will treat it as string only. Okay, we don't have the specific of a character. Then how to display, I need to know that it is a character. So then I'll take the help of type conversions. I'll show that part also. Okay, till up to here, it's clear. Is it okay? The data types? Hello?
Yes, madam.
Yeah, okay, sir. Fine. Now I'll go for the advanced, that is like complex data types and Python data structures. Here itself I define. One second. So yeah, sorry to interrupt. Now coming to here. So here we are using the data types like I'm using data structures. Okay. So now coming to here, we had the part like first one. I'll explain like list part. And the second thing I'll explain about the tuple. Next, I'll go for the dictionaries part. And the next one, sets. So these are the generally advanced data structures we'll take it as. Okay, so what is the advanced data structures? It will be hard like for us. We can take like list is nothing but as in, if I say like it's a list, how can I identify what is a delimiter? Here I'll use the delimiter like this one, square brackets. Okay, if I'm using the list part, I'll use like square brackets. For example, list is like it will occupy different types of values in a single instance. Like in array, we'll say like in C language, array is a collection of similar data elements. Like in the list, it will store the similar and dissimilar data elements itself. So what is the syntax of list here? So here I'll use like a simple variable like x equals to my list I'm using. I know that the delimiter of a list is like square brackets. Here I'll define like own and here 1, 2 and some 3.4 and here I'll use like string format like this. So this is my list part. So when I use like print of x, so what it displays, whatever the list elements. So in the previously data types, what we have sent it a single instance or a single value can be stored in the variable itself. Okay, and we can change the particular RHS value at the any particular instance itself. But coming to here, if I want to perform any kind of an operations in a group, okay, so then I'm using the help of list. So this is my list indication. I can use like multiple data types values here, like string or character, anything. So I'm just printing here. Now I need to know whether my system has been displaying the class of list or not. So for that sake, I'm taking the type method of X. So it will display me what is the data type it has been stored and what are the values it will be displayed here. Okay, this is the list part. And after the simple, the most important like mutable and immutable concept, but try to understand the basic scenario of the tuple first now here. Now, if I want to know it's a tuple, so what is the data type I'm taking here? What is the delimiter? So open and close parentheses. This is the delimiter. So here also I'll use the same. I'll take like Y. So, and same values I'm defining here. And here the type of Y. Okay, next coming to here we are taking like dictionaries part. So here in the dictionaries part also, so we'll know that dictionary. So generally, if you take like an phone contacts, the indexes values like A to Z, those are the keys. Okay, and if I go for example, Anusha, A is a key, Anusha is a value. So in that value, I need Anusha details will become like email ID, fax, etc. So that is not the dictionary where it will be used. If I want to develop an Oxford dictionary application, then I'll use this kind of a dictionary concept. Okay, or else in college websites, if I want to retrieve a student details, complete details from the first year to final year, okay, here the roll number is a key and the values are nothing but the student record. So if I want to apply those kind of an application, then I'll go for the concept like dictionaries concept. So how? So if I want to know this is a dictionary, how can I identify? By using curly brace. Okay, this is the delimiter for the dictionary. Now, the same thing here I'll take. Next part. So we are saying that dictionary contains like key and value, like A is a key and value is like an Anusha. So here, what is the technique I'll take here? Like the key, I'll take it, I mention like name. So this is my key. I'll use this. Name is my key. And now value. So here the value I'll give like Sai. So key and value. Next, like that, I can define like an key is like name, next like age or roll number, etc. Now here I'll define like 20. So this is the dictionary part. Now, if I want to display like Z. So this is the dictionaries. You can define like here numeric also like this. You can define 1, colon some value like Sai. Okay, next 2 colon like Ram, etc. So this is a one kind of a part. Here I had taken the keys are in the format of strings format. Okay, I can take the key as also an integer part also, not for the float. Float purpose will not use any keys. Okay, we can take it as an examples of existing applications only. Now, and the coming to the next one is like sets. But come, you can see here in the list, whatever the values are given. Okay, so this has been the index. I'll spell it as like 0 index. Okay, 1 index 12, like 2 index 3.4. Okay, 3 index RAM has been stored. So whatever the input that the user have entered, those kind of in a scenario only the memory values will be stored in the memory itself. Okay, so it will not stored in the unordered format here, in an order format. You have to check it out like this is the order format. Same for the tuple also. Okay, same thing, 0th index 1 index 12, 2 index 3.4 and 3 index, so on. Now same for the dictionaries also. We are taking the key value first one and the next one we are taking the key value like 8. And these are the values, Sai and 20. Now coming to the sets. The sets will be stored in the different unordered ways. How? You can see here. If I given like in the sets part, Okay, so it's a set. What is a delimiter? Here also the delimiter for the sets, we can take it as like as per our mathematics in the curly brace itself. Now, I can just copy this part. So W here will define something. So this is my set values. Okay, but this will be stored in a different format itself, an order. Okay, sometimes it will display like in a sequence like ohm psi ram. Sometimes it will display like psi ohm ram. Okay, so it's an unordered part. But why we are using this one? When we're implementing the mathematics, like in the pandas, if I want to know the sets parts, then I'll go for this smart. So here W. Okay, this is a sets part. In the set part also, we had different categories like frozen set. Okay, what is a frozen set? In the frozen set, we can add multiple values. Okay, and the data will be in the serial fashion itself. So here, I use the concept like G part, frozen set. Okay, so here I'll define like frozen set will be defined like this. This is a syntax. This is the delimiter for the frozen set. So if I define like here, I need to define like frozen set. Okay, in the frozen set. So this is the delimiter starting, and here we are defining the sets. So here I can take it as like example, OpenCV. Okay, sorry, OpenCV. And here I can take like pandas. Tomorrow you're going to learn like pandas. Okay, and next NumPy, etc. So here this is the part of frozen set. And same here I'll define like P, and next the type of the data I want to know, that is like P. So this is the part of this category. Okay, so Python data structures are nothing but as an we have to remember like dictionaries, list, tuple, sets. Okay, and next I think I didn't given the example of complex data type, no? So that also I'll given here. Complex data type. So here in the complex data type, what I'll do, I'll define like A equals 2, 3 plus 1J. Now here I'll define like print of A, and next I want to know the type also. So type of A. So this is the complex data type. So these are all the data types are available in Python. So I'm just saving here. Let's save the program. Python 3, yeah, okay. Yeah, you can see here. First one. So this is my list data type. This is for my indication purpose. I give like print A bit list data type, and the delimiter square brackets. And these are the values we define. So just I given like print X, whatever the order I have given the values will get displayed here itself. Okay. And next, I want to know that X is a variable. I know that what type of which type of data type variable. So for that, I given like type of X. Okay. So it has been like class list. Okay. And the next one is like B bit like tuple. So the tuples are nothing but as in a parenthesis itself we are given. So I just given by mistake. You can give the parenthesis also. It will display like same thing. Okay. Next. And print Y and the type of the data type. So why it is, I say that B bit is tuple, but the class data type, it has been shown like list. Why? Here in the previous slide, define like square brackets and just erase the concept. Now I modified here the square brackets to the parentheses. I just save the program now. Again, I'll execute. Just see here. See, you can see here now. You can see the B bit tuple, and tuple will be the delimiter is like open and close parentheses, and the class tuple we are defined. Okay, and this is the list delimiter, and come to the dictionaries part. So we know that dictionary is nothing but key and value we are saying here. So key value And next class dictionary part. This is the type, data type. And next F sets. Om Sairam. So I already said that the set is nothing but it is not in the order. It is in the unordered, it will displays. So here I given like Om in starting index of 0. Okay, 1 index and 2 index I given like this. Okay, it has been like displayed Sai Om Ram class set. So now you can see like my frozen set part. Okay, so I have taken like OpenCV, Pandas, NumPy. I can add the data more here. Okay, and next frozen set data type. And the last one, complex data type. Okay, these are the basic data types are nothing but integers, strings, okay, Boolean data type, floating point. You can take it as those are the basic data type or predefined data type. And these are the advanced data types. And why the people will spell it as like data structure is that we are learning just, okay. After that here, if I want to display, if I want to perform like sorting or searching in a group of list of elements, okay, then I have to take the predefined methods itself. So at that time, those predefined methods are nearly 15 for each category. So if I want to implement those things, that's why they spell it as like data structure. Generally, data structure, the definition is group of elements, okay, stored in memory. In that, after storing the elements into the memory, if you want to perform any kind of an operations like traversing, merging, okay, or reverse or pushing operation, deletion operation, insertion, if you are applying those operations on the group of elements, then those concepts will spell it as like data structure. Okay, data structure. The structure is nothing but is organizing the data and memory location. So for each and every kind of a data type of these things will called as like advanced data types. In this advanced data type, we had nearly 15 operations. Okay, I just given only the example here itself and go to the brief concepts here. Okay, how to define list and how to define tuple dictionaries. Now coming to here, what is the differences between? We know that we can identify it is an integer or float or complex data type or Boolean data type based on the RHS value. Now coming to here in the list and tuple, we have the RHS, okay, the same values, but the parenthesis is different. Okay, the delimiter is different. But what is the exact differences between the list and tuple? In the list, after storing the data into the memory, I can modify. That means in the place of Om, I can modify it to the Sairam. Okay, in the place of 12, I can give it as like 12,000. So in the existing, after storing the elements in the existing areas, I can modify data easily. That means the memory will not be created initially now. So these things will spell it as like advanced thing. Here, each and everything will spell it as like an object. Okay, or else we can take it as like when you're performing the basic, we'll treat it as like values. But when you're applying for the advanced operations, then we'll treat it as like object. So I can modify the object also. But here in the tuple, once we create it, the objects cannot be modified. Okay, so that's why the tuples will call it as like immutable. List is nothing but is immutable. We can change the data, mutable. In immutable, we can't change the data. That is like modify the existing scenarios. So that is the differences between list and tuple. Now, if I want to, some programs will be given, like write a program for sorting using tuples. So the data has to be changed, like when you're comparing each and every elements. So then tuple will not be suitable for us. At that time, we'll use list. But the question they have given like tuple, what we have to do? First, we'll do the operation in list. Then we'll convert the list into tuple. Okay, at the last of line of the statement code, we'll just convert the list into tuple itself. So our program code solution will be get ready here. So I'll go to the next concept like type conversion. Before going to the type conversion, so the basic and advanced data type scenarios, is it clear? Any doubts still up to here? Is it clear?
Yes, ma'am.
Okay, fine. Now I'll go for the type conversion part here. So type conversion is nothing but just converting from one data type to another data type. Okay. So what are the type conversion concepts are available here? So just I'm going for the simple. So if I say like, we'll go for the command prompt, this prompt. Now just say me the answer. What is the output for this program? What's the output we'll get here? Just see the idle window screen. What is the output I'll get here? When I given print of 10 plus 20, what is the output will be generated here? Okay, fine. So when I given like a 10 plus, so here it's an integer part we know. Okay, here we are given like a string or integer. 20 is in a string or integer. So both are the integers part will give like 30. Now it's the same statement if I given like 10 plus. Okay, so here plus is nothing but arithmetic operator. Okay, in Python or in Java, the plus can be used like act as two ways. One is like arithmetic addition, other one is like string concatenation. Okay, that is nothing but joining two strings. So here I'll give like sign. So what is the output I'll get here? In the first line, 10 plus 20, both are integers. I got the output like integer output here. In the second category, I given like integer plus string. So what is the output can be generated here? So if I given like 10 plus, that is nothing but just now I said that concatenation. The plus can be used in two ways. Okay. So unsupported. That means I know that it's an integer. Okay, it's a string. Now plus is nothing but I said like it's a concatenation. But why it is not joined here? So you can see here unsupported operand type. What are the operand? Okay, as per your language, operands are nothing but as a what? This one. Sai is an operand, 10 is an operand. Now what I have to do? I need to execute this part. So what I have to do? Either I need to convert the 10 into the string format. Okay, then string plus string. Okay, so it will concatenate. So you can see here. Generally here I given like integer plus integer. I got the integer output here. But here it's an integer and a string. Okay, so I'm saying like plus. Either it has to be joined here. So what I'll do here, I'll use a concept like type conversion. So print. So the 10, either 10 has to be converted into string part. So what is the string I'll take? str of, this is my type conversion of what? 10 plus my version string I given like the data like sign. Okay. Now see here. The previous and now coming to this part. Okay, what is a type conversion? Is like converting from one data type to any data type. Okay, these we had different types of functions like this under the type conversions. Just example here I'm writing here. So we have like int, you can convert. Okay, the whatever the value if we define here in the X place, if I had like a string or else a floating point, okay, complex anything, you can convert. Okay, based upon the integer part. We had like long data type. Long is also one type of integer category. Okay, like that we had like float. Okay, so if you want to know like tuple conversion, okay, list conversion. Here I'm not writing X part in the parameters itself. Okay, like set part. Next, ordinary. If you want to convert a string value, we know that in C language will say like ASCII format. Okay, if you know means the capital small a to small z will start from 97 to 122. Okay, capital A to capital Z will start from 65 to 90. Like alphabets, numbers also 0 to 9 will start from 48 to 57. Okay, if I want to know these values, okay, A is 97 ASCII. If I want to display like that, so I can use like odd. So print, I select print, okay, ordinary. So here I'll define like a single character. The character is like A. Now I want to see the print the ASCII value here itself. So you can check it out. Odd is a type conversion. It just displays the ASCII value of that particular character. Like here, if I given like 1, so here if I define like print odd of 1. Okay, so odd of 1 is nothing but I know that 1 is a character. I'm treating it as a character. I need the ASCII value for that 1. You can see 49. Okay, this is the ASCII chat values. So if you want to display the ASCII values, then we can take the help of order. Okay, and characters is nothing but if you want to convert a single character. Okay, like if want to perform like this integer value into character. So for example, at that time I'll take like CHR character. Okay, so I'll take like character like 48. I want to display like integer value. So 48 is a 0. If I take like print, okay, CHR, I've given the value like 97. It has to display the, sorry, 97 is the value of character, it has to be displayed. Okay, I define the mistakes here. I just CHR. Now you can see. Okay, so this is the type conversion part. Fine. So when you're doing any operations, okay, you can convert based upon these predefined methods. Okay, so set we had learned that the different data types of basic and predefined. So if you define like a predefined or as advanced data types, if you want to convert from one data type to another, you can do it by using the concept of type conversion. For example, last thing here, I'll give one. What's the answer? Just tell me. What is the output will be generated for this line of code? If I given like print of 20 plus 30, what is the output?
20, 30.
So string concatenation. Okay, so if you take anything like int of, if I given like 1 plus int of 2. So what is the output will be generated here?
3.
3, right? Okay, now, so my question is simple program. If I want to display last digit in a given number, what is the logic I need to write? If I want to display last digit, or else if I want to display a digit at one place for a given number, what is the logic? Is the question is clear to you? Write a program, okay, to print the digit at one place or one's place of a given number. Given number. What is the logic? I think it's clear now. This is a question.
Divided by
We have to use 60, ma'am.
We have to use which kind of an operator? Which type of operator? See, if I given the input is like 1, 2, 3, I need to get the output. One's place I'm saying here. So one's place is nothing but as I'm just giving like 3. So what is the logic? What is the logic? Anyone? Hello.
We can use list, ma'am.
No.
Then print off.
No, we
Why?
have to
What is the
divide with
text?
10 and we have to consider that remainder.
Yes. So that only I needed. So why we are taking the list here? He said that not numbers, na multiple numbers, only for a given number. This is a number. So if I take like number equals to 123. So now what's the logic? I need to display the tens ones place of a given number. So here just I'll simply like num of percentile of 10. That's it. Only the tens place and number I needed, na? This is the lines of code. So now just here I'll just simply here. So if I take like n equals to 123, here n modulus 10. Okay. Understood the question? I didn't ask you the take a multiple numbers and perform the operations here. Okay, take one number and find out the just ones place of a given number. Okay, and now come to the next one category. So here I'm going for the next one like operators. So generally in operators, we have the categories like arithmetic operators. Okay, and second one we have like logical operators. And third one category we have like relational operators. Fourth, bitwise operators. Next, fifth one we have like Boolean operators. Sixth, membership operators. Okay, next we have like we can say like identity operators also. Okay, so what is that identity operators? So these are the different types of operators available in Python. So if I take like arithmetic, I had the operators like plus, minus, multiplication, okay, division. So for this, I'll get the quotient value. Okay, and next one is like modulus. And the next we'll get the like, we had extra operators here like first one, floor division operator. We'll call it as like, this is an integer division. Okay, so what is the integer division? Let's see the example. And the next operator is like explanation operator. These are the operators available under the arithmetic. Okay, so first one, if I take an example, let's see. I'll take here itself documentation. So here I'll define like a equals to some 30. B equals to given like 4. Okay. Now, see here I'll written like first one addition. Next, here when I'm printing these statements, what I'll do here is that you can take so A plus B. And the next one minus multiplication, division. Okay, next modulus. Expansion. Next integer division. So here I'll use like explanation operator. Modulus. So these are the operators. So what is the answer I get here? When I use like 13 plus 4, we know that 13 minus 5, we know. Okay, 13 into 4 and 13 divided by 4. Okay, next, this is a modulus, reminder result. Here quotient and it's a modulus, reminder. Okay, explanation, power. And next one here we are saying that this is nothing but as we can call it as like integer division or floor division operator. Okay, what is the purpose? That means it gives only the integer quotient only. Okay, integer quotient only. So for that's getting the integer Now I'm just saving the code here. So see here, see the code and just see the output here. So addition, we have given like a equals to 13, 4 and 13 plus 4. Okay, next multiplication, and this is nothing but as a division operator. It will display the quotient. Okay, and the quotient will be displayed in the format of, when I use like single forward slash, it will display the quotient in the real point values also. Okay, if I don't need any kind of a real point, then I'll go for the float division. Okay, this is the float division. That is the differences between this division operator and float division. Okay, and the next modulus will display anyway, it's a reminder. Next, exponential. These are the arithmetic operators available in Python. Okay. Is it okay? So from this, I want to ask a simple program like, write a program to print the sum of individual digits for a given integer. So the question is that if I given my input n equals to 123 or 124, anything, I need to get the output like, here you need to use a logic. I need to get the output like sum of digits equals to 6. So what is the logic I need to use here? Anyone? Anyone? What is the logic? Is the question is clear? Is the question is clear to everyone?
క్లాస్ అయిపోయింది, టైం అయిపోయింది, అయిపోయింది క్లాస్. ఇప్పుడు అటెండ్ అవ్వు.
Hello.
నేను నీకు చెప్తాను ఈరోజు.
So is the question is clear? How to display the sum of individual digits? We had this number. I need to display the sum. So what's the logic we'll use here? In the previous only we had done one program. Like once place we had taken like modulus 10. So individual digits is nothing but this is the entire number. I need to separate each and every digit. I need to perform the sum operation here. So for that, what is the logic? Anyone? Okay, fine. I'll just say here the pseudocode. So take into the example, till now I didn't use any kind of learn the loops concept. So what I'll do here is that, so first one, I'll take like n equals to n modulus 10. So what is the output I'll get here? 123 modulus 10. What is the output I'll get here? In the last program we did, no? What is the output we'll get here? 123 modulus 10. What is the answer we'll get here? So here the remainder will get the modulus, the remainder result. So when I'm dividing with 10, I'll get the answer like 3. Okay, later I'll take to store the result. I have taken one kind of a variable like imagine s, just imagine like s. So s equals to, what I'll do here is sum of digits I'm saying here. So the last digit I got it here in the first operation. So sum plus t I'll use. Here I'm using the tracing part itself. Okay, what will happen in this line? So initially if I given like s equals to 0, treat it as like that. Okay, what will happen here? So I'm just writing the RHS part here. 0 plus t value. In the previous step, what is the t value here? 3. So I'll get the answer like 3. Next, n equals to, again I want to perform the operation. n divided by 10. So what will happen here like RHS part? What is the value of n value here? Here we have seen that n equals to 123. Okay, so if I take in here like 123 divided by 10, so I'll get the result like quotient. So what is the quotient value? 12. Now what I'll do, I'll just implement the same steps again here. So t equals to n modulus 10. In this n equals to n modulus 10, what happened? What is the previous value of n value here? 12. So 12 modulus 10. I'll get the answer like here 2. Next. So s equals to s plus t. In the previous value of s step, what is the value here? 3. So 3 plus t. T value in the previous step 2. So 2. What is the answer? 5. And next coming to here, in this particular block, what the n value is like 12. So 12 divided by 10, the answer is like 1. Now again, I'll take it as the steps. Okay. And here we'll say like 1 modulus 10. So 1 modulus 10 is like 1 only, reminder. So on the next, previous stop of s value is 5. And here the t value is like 1. And the answer will get 6. And here n divided, that is like 1 by 10. We'll get the answer like quotient 0.0. Okay. So here I'll use like 0. So finally, you can see what is my result here. S equals to 6. Sum of individual digits s equals to 6. These are the tracing steps. These 3 lines are my logic here. I just trace the code here. Is it clear? Any doubts? Is it okay? Is it okay? Generally for writing, if you want to write the program, we have 3 steps here. First one is like sequential programming style. Okay, and the second one, selection programming style. And the third one is like iteration programming style. So what is the sequential programming style? In this programming style, we don't use any loops, okay, any if conditions or else conditions, etc. So we'll just write whatever the logic we know, mathematics, we'll just implement. Okay, see here, based upon my digits, the lines of code has been repeated here. Okay, I have used like n equals to 123. If I take like n equals to 1, 2, 3, 4, 5, I need to repeat the logic like 5 times here. Okay, so this is my sequential programming style. I didn't use any loops. Next, comment here like selection programming style. In this selection, I'll use like some kind of a loops concept. Okay, so what will happen like the loop based upon the loop? Just I'm giving the part. Okay, this category of the style of programming is known as sequential programming style. Okay, the same thing I want to use like selection programming style. Just see here how the selection will be. Okay, selection programming style. So in this selection, what I'll do here is that instead of writing this all those things, simply after writing the statement, 3 lines, okay, this is the tracing part actually. For your understanding purpose, I given like that. So this is my logic. What I'll do here is that here I'll use one label just for understanding purpose only I given. Back, I'll use one label. I can give any kind of a name also. Back is not, it's a keyword or it's a predefined. Okay, it's a user defined only. We can give any kind of a name. Here, what I'll do, if n is not equals to 0 or as n is less than 0, you can keep any condition. Okay. Next, just for our understanding purpose, this kind of keyword is not available in Python. Just I'm giving, go to back. Okay, for your understanding, I need to show the differences here. Selection and sequential. So this is the code. In the previous sequential, based upon the digits, we written the code. But in the selection, you can see here, back. What happens here, the normal execution will becomes here. So if I take like n equals to 123, it will check like 3 value. Next 0 plus 3, 3. Next 123 divided by 10, 12. 12 is not equals to 0. The condition is true. So what will happen? It will enter into the if block, okay, and go to back. So what will happen? It goes to the back. Again, 12 modulus 10. We'll get the answer like, okay, 2. Next, 3 plus 2, 5. Next, 12 divided by 10. We'll get the answer 1. 1 is not equals to 0. The condition is true. So again, it will enter the block. Go to back. Again, go back. 1 modulus 10, 0. Okay, next year, what happens? 5 plus 1, 6. Okay, next year, what happens? The 1 divided by 10. Imagine like it is a 0. 1 divided by 10, 0. Now, 0 is not equals to 0. The condition is false. Come on. What is the observation we observed in the sequential programming? It is taking lines of code increases, but come to the selection, the lines of code has been reduced. Okay, but coming here, one point, we should not use Goto. Generally, Goto has been removed from the Python as well as in the Java also. Just for selection style programming, I just given here. In single program, multiple ways. Okay, to overcome that, what be the style we are preferring now? The third style is like, that is like iteration style. So what is the iteration style here? I prefer like iteration style. So we'll not use this one. So generally here we'll use like while. Here I give the condition like while is n is not equals to 0. Just I'm giving the curly brace like, okay, in Python indentation. This is a logic. So here we are not skipping the code here. We're executing each and every line. Okay, and it is very simple. And the n number, if I given like n is like 3 digits, we are not writing 3 times the logic. Based upon the condition, the loop block will be repeated. Okay, this is the while part. Fine. So how the while will be executed? The same programs we can do in the Python also. The tracing part here, I'm just saying here. So 123, the loop will be repeated and it is executed. Okay, these are the generally for any kind of a programming, we had 3 styles: sequential, next selection and iteration programming style. Now, if I want to write the same code, okay, we can go for the functions or recursions, etc. So this is a simple program. So how if I given the question, we have to think in different ways. Which style is convenient for this kind of get the solution, perfect solution. And we have to remember the time and space complexity also. The lines of code, if you want to become like a good programmer. So these kind of things we have to remember and we have to think. Next. So these are the operators. But why we have got this program is like, we have learned these simple operators. We are just implemented here. So and the next type of operators we had like, so you can take the same thing. So we had like operators like relational operators. So in relational operators, we have like less than, greater than. So same thing here directly you can implement. So greater than. And next we have like less than equals to, greater than equals to. Next year going for equals to, not equals to. And the next one we can go for the operators and that we discussed. So we had the Boolean data type. Based upon that, the values will get printed here. Whereas in Boolean, we had only true values, constant values. That is like true or false here. saving. See here. See the code. So A equals to 13 and B equals to 4 we are given less than part. Okay, that is like 13 is less than 4. Next, same thing, 13 is greater than, 13 is less than equals to, greater than, equals to, and not equals to. So where this operators will be used if you want to find any kind of an numbers greater or larger, or if you want to perform like ladder case conditions, at that time these relation operators will be used. Okay, if I want to check more than one condition, generally what will say like this is like condition. Okay, every condition must be enclosed with parentheses. This is a condition. Okay, if I want to check more than one condition, then I'll go for the logical OR operators. Okay, what are the logical OR operators we had? Like AND or NOT. Okay, so if you take this one, here itself, here I'll use like logical AND. Okay, and next here I'll use like A is greater than B. Next, this is one condition, big condition here. And I'm just closing the print statement here. Or just logical or unlogical and. So what I'll do here is that instead of that directly I'll give the number. So not A. So how this will be evaluated first? This is the outer parenthesis. First inner parenthesis has to be evaluated. So 13 is less than 4. It will be evaluated first. It will display like false. Next, later, next inner parenthesis, true, false and true. We know that Boolean or gate operations. Okay, so based upon that, we'll get the output here. And next, not A. What is the purpose here? That means if my A value is a positive value. Okay, so if I say like not A, it will display the negative value here. Okay, these are the operations we had. So these are the logical operators, and the same thing we had like bitwise operators also. So that means bit level operations. If you want to perform bit level operations, then we'll go for the bitwise operators and or not complement. So we have a lot of operators under the bitwise. Just I'm giving here. So we know that AND operator, next OR operator, byte symbol, next complement operator, that is like one's complement, next XOR operator. Okay, and next one left shift operator, right shift operator. Okay, we have like in Java we have like right shift operator, but these are the total bitwise operators are there. So that means what is the differences between logical and bitwise is like in bit level, the total value, the decimal value will be converted into binary. Then it will perform the bitwise multiplications there. Okay, so when the bitwise operators will be going to be used at what type of programming? If you want to convert the decimal to binary conversions or binary to hexa, at that time bitwise operators will be helpful for us. Okay, 2 lines of code we can return. So for converting from one number system to another number system, at that time we can use like bitwise operators. And the next one we have like complement. We know that one's complement, two's complement we learned. Okay, so if you want to implement like one's complement, we'll go for the bitwise one's complement operator. And now coming to the next one, I'll go for the membership operators. Generally in membership operators, we had in and not in operators we had. So what is the purpose of like in and not in? So in a given list, if I given a list, a group of elements, I want to check it out whether whatever the elements are there from the starting to ending, it will display each and everything. That is the in operator. Okay, not in is nothing but the opposite of in. So it will returns like the in checks each and everything. The element is there. If it is there, it will return true and it will execute the part. So I'll just show the simple program here for you. So here itself, I'll write. For example, if I take like names. So here in the names, I'll define like Om, I, Ram. So this is my list. Just remember, I want to display one after the other. So if I want to display like one after the other, I'll go for the loop concept only. Why? Because it's an index. You can see here, print names of, I say like 0. It will, this is nothing but as an indexing. That's a concept called as like indexing. That means 0th index, Om, 1, Sai, like that. And next one, we had the concept like slicing. So 0th index to, if I given like this one, generally we had 2 types, starting index, ending index, and increment value. So if I say like increment value like 1 plus 1, it has to be added. This is the slicing syntax. Starting, okay, ending, and increment. So if I say like 2, it will jump 2 times plus 2. Okay, this is a slicing operator syntax. Now, but I want to display like the serial values. What are the group of values one after the other? Then I prefer like loops. In Python, we had 2 types of loops. One is like while loop and for loop. So here the for loop syntax is for is a keyword. Okay, and what are the values you want to display? So I'll take it as like names. We had a group of values like Om, Sai, Ram, like that. One after the other, it has to be displayed. For that purpose, I've taken the variable like I. I use my temporary variable. I can use like J or anything. Now, in operator, why? Because these are the names as having a group of elements, that is like member. So here, if you want to display the values, a group of values, then we'll use the takeoff help of membership operator. The membership operator here take like in. Next, the syntax call. So I say like indentation. So here I'm using the notepad. I didn't use like the graphical user. So for getting the indentation, 4 spaces. So 1, 2, 3, 4. So here I'll use like print of name. That means I'll display like I, one after the other. This is my code. Okay, now just saving here. See here. So the logical AND operators, I said how the evaluation will be going on. Now see here names. This is my list. I know that square brackets are the delimiters. Now names of 0 have given 0th index value. So that is like Om has been displayed. Next one have taken like slicing. The slicing syntax is starting number from starting to ending, but plus 1. Okay. So if I then 0, 1, 2. So starting index you are given and 1 and 2 index is also then we'll say like plus 1. It has to display like Om Sai Ram. So at the ending index, it will take like minus 1. That means like 2 minus 1, 1. So it has been displayed only 2 index values here. This is the slicing operation. This will be used for us when we are doing like searching operation or sorting operations in group of elements. Okay. Now, what I said that what is the purpose of in operator? That means how to display this group of elements. These are the members. Okay, one after the other by using in. So I have taken the temporary variable. Okay, in. So it will check that I. In, what is the in? We had like Om Sai Ram. So Om value is there. So it returns true. Sai displays the Om value. Next, it will goes to the loop again. So Sai. So value is there in a list. It returns true. So it will display Sai. Next Ram. Next, there is no value. So it will return false. It is come out of the loop itself. This is the for loop syntax of Python. Okay. And this loop will be used for tuples. Okay. Arrays or strings or list dictionaries, sets, frozen sets, etc. For advanced data structures, we'll use this loop. Okay, if I want to display this one using while loop means what we'll do here is that we'll take like first one. For my understanding purpose, I take it as like I equals to 0. Okay, next I'll take like while condition here I'll specify like, so I need to display all the values. So what I'll do here is that simple I is less than equals to, I don't know the syntax of this one. So I'll take it as print length. It's a predefined method of names. So it will display the length values like 0, 1, 2 like that. So here I'll take it as just remove. I'll give like this. Okay, colon. Next. Here I'm not using the predefined. So 1, 2, 3, 4. Here I'll define print the I value. Or else you can give like names of I with index. Next, I value has to be incremented. So here I'll take like I equals to I plus 1. So this is like increment. So here in the LHS I and the RHS I, so immediately it has been occurred. We can write this statement in another way like I plus equals to 1. So this is my while loop syntax. So if I want to write down the loops program, first one initialization. This step is like initialization. And the second one is like condition. We need to remember this all those things. And the next one here is like, this is updation. For every loop, we need to follow these conditions: initialization, condition, updation. Just for syntax purpose, given here. Now see here. So here I'll use in the while loop here. First, I is less than that length of names. It will display the length value of your list. So if you have that kind of dot here, you can use one statement like print L length of names. Like you can do like names length equals to. Sorry, I forgot the name quotation. Here I use in the single quotation, here I use in the double quotation. Now see here. So names length equals to 3. So why? Because length of names we can understand. So I value 0. 0 is less than 3. The condition is true. So names of 0 value has been displayed like O. Next I value will be incremented to 1. 1 is less than again 3. The condition is true. So names of 1. Sai. Next 2. Next the condition is true. It will be displayed. The loop will be repeated. This is the for loop syntax in Python, and this is the while loop syntax. So till up to here, is it clear? Any doubts? I didn't see the chat box. Sorry. So is it clear now? While loop and for loop syntax? Is it okay? So that the sum of digits we have written the program now, you can practice like write a program to find the reverse of a given number. That means I need, if I given like input like n equals to 123, I need to get the output like some r equals to 321. So here, what is the logic we'll use? Anyone? What is the logic? So what is the logic here for finding the reverse of a given number? So what is the logic will be here? So in the previously we did like sum of individual digits now. The same thing you have to manipulate here. Okay, just you need to change that one. For example, if you take this one, if this is a question, so if you take like n equals to number, so you can take it as like integer. So I'm reading the value, not only this one, So why I'm using the type conversion like int is like, so default it will treat it as like string. So I need to convert into integer. Next later, if you take like some r equals to 0 for storing the result. Next here, you can take like a loop concept or else some t value also, the same previous value program. So here I'll use like loop. So n is not equals to 0. Here I'll use like t equals to n modulus 10. Next, here you can take like reverse. So for reverse, I'm taking like r into 10, the same logic. Here I need the float division, right? Because I don't need the quotient real point values. Next. So this is the logic. So I'm just saving here. So if I give like 123, now see here. The tracing is same here. The tracing steps is same here. So if you take like 123 here, 123 is not equal to 0, it will comes here. So the condition is true. So 123 modulus 10 will get the answer like 3 here. Now again, 0 value anyway, and we have taken like 0. 0 into 10, 0 plus, what is the t value here? 3. So r is being stored into 3. Next, here float division I used. So 123 divided by 10, I'll get the answer like 12. So if I use like integer division, so I'll get like 12 point real point values here. So to overcome that, I just use in the float division. That's the purpose. Okay, and the loop will be repeated. Again, 12 is not equal to 0. Again, 12 modulus 10 will get the answer like 2. Now here, previously R value is 3. 3 into 10, 30. 30 plus 2. 32 will get here. Next, again, it will displace like 12 divided by 10 will get like answer 1. Again, the loop will be repeated. 1 is not equal to 0. Now 1 modulus 10 will get answer like 1. So previously R value is 32. So 32 into 10, 320. 320 plus T value is like 1. 321. And here 1 divided by 10 will get like 0. Loop will back. 0 is not equal to 0. The condition is false. Come out of the loop and you will displace the number. R value output is 321. Okay, this is a tracing part here. So if you understood this logic, you can perform like a palindrome or else Armstrong or a strong number like that. Okay, is it clear? The concept?
Clear, madam. Madam, shall we conclude?
Yeah. Okay. Okay.
Dear participants, if you have any doubt, please raise your doubts so that madam will clear your doubts.
I think the people didn't understand the concept. I think so.
Good afternoon, ma'am.
Yeah, good afternoon, sir.
Any have the preparing the book on Python, the best book?
Sir, best book I can't say. Sir, book is not like, sir. We had you, if you take one topic, refer different sites. That is better. So if you go for the book now, they're given the different types of, why? Because older versions will be there in the book. Updated versions is like Python 3.9, na?
Ah,
So
yeah.
it will not be updated there.
The
better
programming purpose,
For programming,
yeah.
the programming, you can refer like Rima Tereja, Oxford,
Which one, madam?
Oxford University Press, Rima Tereja.
Immaterial. Okay.
That is one book you can refer.
Okay, thank you.
Okay. And you can refer like Dream Tech Publications, Dr. D. Nageshwar Rao. Black Book.
Nageshwar Rao.
Dr. D. Nageshwar Rao, Dream for Core Python.
Right. Okay. Thank you.
Okay, sir. Welcome, sir.
Madam, shall we conclude, madam?
Yeah, okay, sir.
Okay, madam. Thank you, madam. Thank you very much.
Okay, sir. Thank you.
Está. మీ దాంట్లో నాకు గూగుల్ ఫామ్ ఓపెన్ చేసి నాకు ఓపెన్ చేయవచ్చురా?
కాదు అది ఒక ఐకి ఒకటి ఒకటి పోతా అనుకుంటా పోతుందా? ఏమో మరి నేను కాంటాక్ట్ చేస్తున్నా.
నేను ఇక్కడే ఉన్నా పోలా. సార్ మన ఇద్దరం ఒక రూమ్ తీసుకుందామా? అర్థం కావట్లే. ఓవర్ చేయొద్దు, నాతో పాటు వచ్చు. సారీ సార్, ఎవరితోనైనా వెళ్తాడులే. నేను 20 దాళ్ళే అయ్యా, పావుగంట పైన నిలబడుకుంటాం. గూగుల్ షీట్ ఓపెన్ చేయాలి. నా దాంట్లో డౌన్లోడ్ అవ్వట్లేదు భయ్యా. ల్యాప్టాప్
ఫ్రిడ్జ్ ఉంటాను, ఫ్రిడ్జ్ లో ఏం లేనిది ఫ్రిడ్జ్ అని అన్నారు కదా, 60% మార్క్స్ ఉండాలా, 80% అన్నారు. నువ్వు భారత్ అటెండ్ అయినా కదా, ఫ్రిడ్జ్ ఉంటుంది, 2 ఉంటాయి. భారత్ బిఐఈటి ఇబ్రహీంపట్నం భారత్లో వేసారా?
సినిమా ఫోటో దిగటానికి పోవాలి. ఫోటో దిగటానికి దేవరాక్షం చేస్తున్నాడు అమ్మ.
మనము ఇట్లా సబ్మిట్ చేసినట్టు కన్ఫర్మేషన్ రావాలి, మెయిల్ రాదు కదా, అక్నాలజ్మెంట్ మెయిల్ కొందరికి వస్తుంది. కాంటాక్ట్ ఉంది కదా, మేము చేస్తున్నా పైథాన్ మ్యాట్లాబ్ 2 1 month కోర్స్. అది FDP కాంటాక్ట్ ఈ-లెర్నింగ్ అని, కంపెనీ.
ఎంత ఫీజు?
ఫ్రీ. మనం ఫోన్ పే చేసినాం అనుకో, ఇంటర్న్షిప్ మనం ఎలిజిబుల్ అనమాట. ఇంటర్న్షిప్ కూడా అసలు ఇస్తాడు, ఇంటర్న్షిప్ చేసినట్టు కూడా చేసుకోవాలి. ఎందుకు
నా పంపేది
అయిపోయింది. అది 25 మీ క్లాస్ ఉండాలి కంపల్సరీ, అవుట్ ఆఫ్ 30లో. ఇప్పుడు మ్యాథ్స్ సమ అయిపోయింది. అది
మళ్ళీ ఒకవేళ పెడితే ప్రిన్సిపల్ ఉన్నాడా?
సిగ్నల్ అయ్యాది ఓపెన్ అవ్వట్లా.
ఇందులో ఏం లేకుండా
అదే చెప్పా నీకు. దీంట్లో ఫామ్స్
మీకు ఏమేమి వీడియో ఇప్పుడు కాల్ చేస్తుండే స్కార్స్ చేసి అనుకుంటా. లింక్ మేడం లింక్ ఎక్స్పైర్ అయిపోయింది అనుకుంటా.
madam. You can share your.
Good afternoon, sir.
Good afternoon, madam. Madam, let me introduce, madam. Dear participants, for this session, our resource person is Dr. S. Anuradha, madam, from NIT Warangal. She is currently working as associate professor in the Department of ECE at NIT Warangal. She received her BTech and MTech degrees in ECE from the University of Nagarjuna in 1999 and Sri Venkateswara University in 2001, and received PhD degree in ECE from the Andhra University, Visakhapatnam in 2012. She has been teaching for more than 20 years. Her current research interests are in the field of wireless communications, cognitive radios, and coding theory, feeding channels, etc. Currently, 7 scholars are working under her guidance, and 5 scholars have completed their PhD in her guidance. Based on her research work, she has published more than 90 research papers in various international journals and conferences. She has completed 4 research projects under MHRD, DRDO, and DST SERB, and recently she received one DST SERB project with the worth of 33 lakhs. She is the reviewer for various international journals. She is the author of the 3 book chapter published by Springer Publications. She also received a DST travel grant to attend the reputed international conference in France, Crown Com 2016. She has visited Italy, Dubai, France, Singapore for presenting her research papers. She is the department coordinator for International Erasmus Mundus program Heritage. She also conducted several FDP programs at NIT Warangal. She has given many guest lectures in various engineering colleges and universities for UG, PG students and faculty. This is a short introduction to Dr. Anuradha madam. So before moving ahead, I request all the participants kindly mute your mic and camera. And if you have any question during presentation, feel free to write in chat box. Your active participation is important throughout the session. Without taking much time, I would like to invite Dr. Anuradha madam to start this session. You can start, madam. Over to you, madam. Thank you.
Thank you, sir. Thank you for your brief introduction, sir. Am I audible to you, sir? Hello,
Madam. Yes, madam. Audible, madam. Audible, madam.
Okay. Yeah. Thank you, sir. First of all, I would like to thank the management of MLR Group of Institutions, Lakshman Reddy, sir, Rajashekar Reddy, sir, and principal of this college, Professor K. Srinivas Rao, sir, and program coordinator of this workshop, Professor SVS Prasad, sir, for giving me this opportunity to deliver a lecture on index modulation techniques for 5G wireless communications. I congratulate the Department of ECE for conducting this Python programming for 5G wireless communications AICT sponsored workshop. Thank you, sir. Once again, thank you all. Thank you, sir. Can I share my screen, sir?
Please, madam. Please share, madam.
Okay. Sir, my screen is visible to you?
Yes, madam. Yes, madam. It is visible, madam.
Okay. Thank you, sir. Today I am going to present my presentation topic is index modulation techniques for 5G wireless communications. First of all, why I am going to choose this index modulation techniques? Is there any specific reason using index modulation in 5G communications? Actually, you know the normal modulation techniques, digital modulation techniques, how to calculate BER, and what are the performance metrics of wireless communications, especially, and before 5G, what are the generation techniques, and what is the difference between second generation to third generation, from third generation to fourth generation, from fourth generation to the fifth generation, how the data rates are increases. Just I will give you few slides before start my actual topic of index modulation. And there are important metrics in 5G wireless communications. What are the performance metrics means? Bit error rate is one of the performance metric, spectral efficiency, energy efficiency, latency, and capacity of the channel, and signal to noise ratio, and peak to average power ratio. All these are the all characteristics of the channels are performance metrics of wireless communications, not only 5G. Generally in wireless communications, these are the performance metrics. So before start this advanced modulation techniques, just I will give you brief introduction of generation techniques. A wireless technology standard for exchanging data over short distances. Any data or information can be transmitted faster and with a high speed. Each generation of data network gets faster. We saw the second generation. So actually this is started from around 1999. The third generation from 2001. And fourth generation in 2012 till fourth generation, almost all standards are finalized. Now we are moving to fifth generation and beyond the fifth generation also. So in all generations, 2G, 3G, 4G, and 5G are all indicators of signal strength and downloading, uploading data. So to downloading the data and uploading the data, it's a fastly uploading and downloading, and increase the data rates from second generation to third generation, third to fourth, and so on. So approximately in 1990s, the second generation technology is global system for mobile communications. Not only these four, if other technologies are also under these generations. What are the data rates of, especially in the second generation, the name of the technology is global system for mobile. Approximately the data rates are 10 kilobits per second. And the second generation under CDMA, like code division for multiple access technology, the data rates are 10 kilobits per second. And 2.5G GPRS, global packet radio service technology, the data rates are approximately 50 kilobits per second. And 2.5 generation or 2.75, like edge technology, enhanced data for GSM evaluation, the data rates are approximately 200 kilobits per second. Even from this table, from second generation to 2.75 generation, the data rates are increases. From second generation to third generation, again the data rates are increases. Like in the third generation, approximately in 2000s or around 2001s, under third generation, the technology is WCDMA and UMTS, like wideband code division multiplexing technique, and UMTS, Universal Mobile Telecommunication Standards. The data rates are approximately 384 kilobits per second. And third generation and CDMA 2000 technology, the data rates are approximately 384 kilobits per second. And 3.5, high-speed downlink packet access or high-speed uplink packet access, the data rates are approximately 5 to 30 megabits per second. And 3.5 EVDO technology, evaluation data optimized technology, the data rates are around 5 to 30 megabits per second. In 2010s, approximately, the fourth generation technology is long-term evaluation technology, LTE. The data rates are 100 to 200. From second generation to, it's a 384, maximum 5 to 30 megabits per second. Here, 10 to 30 gigabits per second. From mega to move to giga under fourth generation and fifth generations also. In fourth generation LTE technology, approximately 100 to 200 megabits per second, and WiMAX technology, worldwide interoperability for microwave access technology, the approximate data rates are 100 megabits per second. And fifth generation technology is, under this technology, there are many waveforms, 5G waveforms, but under developing stage only, it is not finalizing the standards. One of the example of 5G waveform is non-orthogonal multiple access and UFMC, universal filtered multi-carrier, and generalized frequency division multiple access, and FBMC, filter bank multi-carrier, massive MIMO, and MIMO OFDM. There are many like 5G waveforms. So the approximate data rates are 10 to 30 gigabits per second. So this is the application of each and every technology and generations, like 2 to 2.5th generation. Already we have seen in the previous slides for data rates and applications, like especially for voice applications and basic data downloading is the application of second generation and 2.5 generation technology. And 3 to 3.5, what are the applications comes under this technology is voice, high-speed data, and video calling. So then fourth generation technology, what are the applications like online gaming and HP TV. And fifth generations, massive connectivity for new applications for mobile, e-health, autonomous vehicles, smart cities, smart homes, and the Internet of Things. So these are the applications of 5G. And coming to this is the theoretical speed of each generation, and what are the features of second, third, fourth, and fifth generations. Like what is the theoretical speed of second generation technology is 9.6 or 14.4 kilobits per second, and 3.1 theoretical speed, and data rates both are same only. And what are the features means like indirectly it is nothing but applications only. Like in the second generation, enabled phones were used for making calls and transferring data. And the third generation enabled fast data browsing on your mobile devices and paved the way for video conferencing and streaming. And 3.5 generation, even fast data transfer. And fourth generation, incredible fast downloading speeds paved the way for HD streaming. Whereas in the fifth generation, ultra fast internet, low latency, the latency of fifth generation is 1 millisecond. And fourth generation is 10 milliseconds only. And improved the reliability. So not only these like applications or features, and spectral efficiency and energy efficiency is also going to improve in 5G wireless communications only. So from 4G to 5G, increasing demand for high data rates and quality of service is better, and fully mobile and connected wireless networks. New solutions beyond 4G wireless communications are required. So what are the solutions means 10 times higher than the spectral efficiency and 10 times higher than the energy efficiency. There are many techniques are used to improve the spectral efficiency. Like using MIMO system, spectral efficiency is improved. Using massive MIMO technology or massive MIMO system to improve the spectral efficiency, but at the same time, energy efficiency is decreases. So how to manage both? Spectral efficiency is improved, but at the same time, we are not losing the energy efficiency. That is the aim. Then current 4G wireless networks and will support to data rates up to 10 gigabits per second. These are the demands of from 4G to 5G. So what are the physical layer solutions of 5G networks, like massive MIMO systems and filter bank multi-carrier modulation and relaying technologies and millimeter wave communications are also they are strong waveform candidates for the physical layer design of 5G networks. So in this presentation, we deal with potential and implementation of index modulation techniques for how this index, first of all, how these index modulation techniques are used in especially for 5G communication means to improve the spectral efficiency and to improve the energy efficiency only. So I am concentrating spectral efficiency and energy efficiency of 5G waveforms by using index modulation techniques. And what is the difference between normal digital modulation techniques and index modulation techniques? And how many types of index modulation techniques? And what is the concept of index modulation technique? So we focus on like at least one application, first types of index modulation techniques, then applications of index modulation. Application means like OFDM IM, MIMO IM, massive MIMO IM, then NOMA IM, FBMC IM. So index modulation based multi-carrier transmissions is the applications of index modulation. So especially in 5G communication and beyond 5G communications, index modulation techniques are used instead of normal digital modulation techniques. So now before start index modulation techniques, modulation over one non-fading channel. So you know the fading channels, one of the research area is fading channels, like Rayleigh fading channel, Russian fading channel, Nakagami M fading channel, Weibull fading channel, and height fading channels. And combinations of fading channels are also like advanced fading channel techniques, like alpha mu is one of that fading channel, and like combinations of fading channels. One of the research area in wireless communications is fading channels. And the second research area is different modulation techniques, like using normal digital modulation techniques and using index modulation techniques, and comparing both normal and index, how the spectral efficiency is improved, how the BER is improved. So that is one of the research area. And even in the fading channels also compare non-fading channel and fading channel performance. Along the x-axis is SNR and y-axis is bit error rate, fading channel and non-fading channel. Non-fading channel is AWGN is the non-fading channel, additive white Gaussian noise channel. BER performance is compared to the fading channels. Even without considering any system, That is one of the performance plot. Suppose you can choose any one of the multi-carrier system like 5G waveform or 4G waveform. First, easy to compare all fading channels and non-fading channels. You can consider like a 4G waveform, like OFDM is the waveform. You can select OFDM system, and by applying different fading channels and non-fading channel and compare the performance, then you can move on from 4G to 5G. You can select like NOMA system, and using different fading channels and non-fading channel, and compare out of all fading channels which fading channel performance is better. You can pick only that particular fading channel and compare 4G and 5G waveform. So especially suppose, for example, if Nakagami is the gets the best performance, or BER is better than the other fading channels, so you can select only Nakagami fading channel and OFDM system and a non-OF NOMA system. Compare these two performances. So actually this is one type of the area of wireless communications, research area. Especially I am talking about research areas only. And PAPR reduction techniques. Suppose, for example, there are many PAPR reduction techniques are available in the literatures, like clipping, compounding, and partial transmit, or there are many techniques, PAPR reduction techniques. You can select one 4G system. Already you have taken 4G and one 5G system, and by applying actually one of the objectives channel, and another objective is PAPR reduction techniques. So almost all PAPR reduction techniques programs are basic programs are available in the internet. So take that program and introduce in your system, and compare the how much power will be reduced compared to the without PAPR, like original system, and with PAPR system, and compare the performance. So the same technique is used in the 5G system also, and compare the performance, like OFDM. What is the, suppose one particular SNR, like one lower SNR, one middle SNR, one high SNR. There are 3 different SNR values, so just you can take. And suppose if SNR equal to 5 dB, what is the corresponding BER and PAPR also? How much, what is the peak to average power ratio in OFDM system? Similarly, with the same SNR, already you have taken 5G system with the same PAPR reduction technique, and compare these two. Actually, this is one of the research area. And another recently, researchers are doing current research area is machine learning based wireless communications. Machine learning or deep learning means it can be used at the receiver side. That is one type of the optimizations only, like CNC, and there are many machine learning techniques. So one by one without machine learning, like normal decoders are there, like ML estimation technique or MMSC estimation technique. So all the estimation techniques are used at the receiver side only. So similarly, in the machine learning techniques, in place of detector, suppose we have one system. In that system, suppose in the OFDM system, transmitter, at the transmitter side, we have so many blocks of transmitter, like IFFT, cyclic prefix, modulator block, filter blocks, like that only. And after the channel, anyhow channel is, suppose if it is non-fading channel, AWGN. Suppose if it is fading channel, in place of AWGN, just you can put fading channel only. Relay fading, Russian, and all types of the fading channels. At the receiver side, we have a decoder. In place of that decoder, just you can introduce machine learning techniques, one by one machine learning techniques. Even basic machine learning techniques are available in the internet only. just you can select one of the machine learning techniques and incorporate at the receiver side in place of the normal decoder only, and compare the performances. So without deep learning and with deep learning. So how to take the results I am talking with deep learning and without deep learning. That is actually one of the research area, machine learning based wireless communications, and even in the index modulation based wireless communication, suppose in OFDM using normal modulation techniques and applying index modulation techniques and compare the performances for different channels. Almost channel estimation is one of the research area, equalization is another research area, and PAPR channels and different modulation techniques. So this is the only these are the research. And one more important area in wireless communications is resource allocation also. Resource allocation is one of the research area related to wireless communications. All are under physical layer only. I am talking about physical layer research problems. Suppose we go for the network layer, there are other types of the problems only. And before start index modulation, modulation over a AWGN. This is the simple AWGN channel model. Like this is continuous time AWGN channel model. Here we have modulator and channel, AWGN channel, and receiving filter and a decision device. So to take a decision, whether the estimated bit is whether it is a 1 or 0 only. This is transmitted bits, and A cap is estimated bit only. So here bits of transmitted are bits to be transmitted through a modulator. This modulator is converted bits to transmitted waveform or a transmitted signal S of t only. S of t, N of t means it's a continuous time channel only. Suppose in the discrete time channel, S and N only. So S is equal to symbol here, transmitted waveform or a transmitted signal S of t, and N of t is channel noise. What are the properties of additive white Gaussian noise channel? So the important property of AWGN is power spectral density is flat, and the power spectral density of AWGN is equal to N0 by 2 is power spectral density of AWGN channel. Additive white Gaussian. Why the name is called white means, so the power spectral density is constant throughout all the frequency components only. And R of t is equal to, this is the channel model, AWGN channel model. R of t is equal to S of t plus N of t only. So S of t is a transmitted signal, and N of t is noise is added to the transmitted signal after the channel. So the received signal is equal to R of t only. So again, this is passed through a filter. So that is equal to information about the waveform after filtering at the receiver side. It is equal to R, and take a decision whether the decision is favor bit is 1 or bit is 0, because there are two possible bits only, 0 and 1, and sequence of bits. So what is the estimated bit? If the estimated bit is equal to the transmitted bit, there is no error. If the estimated bit is not equal to the transmitted bit, some error is received at the receiver side. Definitely we are not equal to A cap equal to A, because through the channel only, definitely channel is a random nature of the channel. So definitely the noise is added to the original transmitted signal only. And discrete time AWGN channel. This is the discrete time. R is equal to, if the bit is converted by the symbol, so the representation of the symbol is S, R equal to S plus N, and again it's a decision device. the estimated symbol is equal to S cap. This estimated symbol is mapped to a D mapper, and whether it is bit 1 is received and bit 0 is received. The receiver filter produces some sufficient statistics. Like this is the discrete time AWGN channel. And modulation schemes. Actually, these are the normal modulation schemes, like digital modulation schemes. We know the some of the digital modulation schemes, binary phase shift keying, BPSK, generally in almost all multi-carrier transmission systems. So simple modulation technique is BPSK, BPSK and QPSK and QAM modulation techniques. Like the higher order modulation techniques are 4 QAM, 8 QAM, 16 QAM, 64 QAM and 128 QAM. So these are the higher order modulation. QAM modulation is the higher order modulation, and the lower order modulation technique is BPSK is the lower order modulation technique. And the bit error rate is better using BPSK modulation because the error levels are less compared to the higher order modulation techniques. Whereas in the higher order modulation, if the more data is transmitted at a time compared to the BPSK modulation, but the noise levels are more compared to BPSK only. So we are compromising the noise, and our aim is only increasing the data rate. We go for higher order modulation techniques only. So without compromising any noise, but whatever data is transmitted, ultimately the error will be reduced is our aim. We go for BPSK modulation technique only. In BPSK modulation technique, actually this is the modulator. Bits A is converted to symbol, or bits are mapped to a symbol. So bit is equal to suppose 1 and the symbol is equal to S. Suppose symbol 1 is, symbol means it contains like more than one binary bit also. Suppose in the BPSK modulation, how many binary bits or how many transmitted bits or how many symbols? There are 2 symbols, binary, only 2 symbols, symbol 0 and symbol 1. So symbol 0 contains only 1 bit, and symbol 2 contains only 1 binary bit only. Whereas in the QAM modulation, symbol 1 contains 2 binary bits, like 00 is the binary bit, and symbol 2, there are 4 symbols in 4 QAM modulation. Each symbol contains 2 binary bits. At a time, we are transmitting 2 binary bits. So the data rates, more data is transmitted from transmitting station to the receiving station only. But the data rates are increases, maybe there will be a more chance to get error from one symbol to other symbol. So that's why the error is more here compared to the BPSK. In BPSK, only 2 symbols, symbol 1 and symbol 0. So symbol 1 is mapped to +1 and symbol 0 is mapped to +1 and symbol 1 is mapped to -1. Or you can symbol 0 is mapped to -1 and symbol 1 is mapped to +1 also. That is your assumption only. You can take either 0 is mapped to -1 or 0 is mapped to +1 initially, assuming if the symbol 1 is mapped to which mapper. And the phase shift of this BPSK modulation is 180 degrees phase shift only, because 0 and 1 are the symbols only. Each symbol contains only 1 binary bit. So here QAM modulation, 4 QAM, M equal to 4 and 4 symbols. So each symbol contains 2 binary bits. 16 QAM, each symbol contains 4 binary. These are the constellation diagrams of digital modulation techniques only. And coming to BPSK over channel. BPSK over AWGN channel only. So this is the in place of the modulator, we know the AWGN channel. So in that channel model, the first block of AWGN channel is actually modulator. So here it's a modulator only. In place of modulator, I am choosing BPSK modulator only. So this BPSK modulator, there are only two symbols, symbol 1 and symbol 0 only. The received signal, this is the discrete AWGN channel using BPSK modulation. The received signal R is equal to S plus N, where S is the transmitted symbol and N is the channel noise, and S cap is estimated symbol. And again, at the receiver side, we are using BPSK demodulator or BPSK demapper, and the estimated symbol is mapped to a bits only. So here in this example, BPSK over AWGN using an optimum decision rule also, how the error is appear at the receiver side only. Suppose if the bit stream is 0, 0, 1, 0, 1, 1, 0, 1, 1, 0, 1. This is the input bit stream. In this input bit stream, the symbols are, if the 0 is, it's a BPSK modulation. Using BPSK modulation, if symbol 0, bit 0 is mapped to +1 and bit 0 is mapped to +1, or you can map 0 is mapped to -1 also. That is also correct only based on your assumption to design and calculate bit error rate only. And here I am using bit 0 is mapped to +1 and bit 1 is mapped to -1. 0 is mapped +1 and 1 is mapped to -1. There are two symbols, 0 and 1, and +1 and -1. So then the received signal is, the received symbol is equal to, or received signal is equal to, R is equal to 0.8 here. So when R is equal to 0.8 means how much noise is added? Please respond anyone. How much noise is added? So what is the equation? R is equal to S plus 1. R equal to S plus N. R is equal to, the received signal is 0.8 and the transmitted symbol is equal to +1 and noise. So N is equal to 0.8 minus 1. So minus 0.2. So N is equal to, noise is minus 0.2. Noise, it may be positive noise and negative noise only. The received signal is 0.8 means added to the original signal is minus 0.2 noise is added to the transmitted symbol. And similarly, suppose here R is equal to 0.2. R is equal to 0.2 and S is equal to transmitted symbol is equal to 1. 0.2 minus 1 minus 0.8 is the noise. So minus 0.8 noise is added to the original signal only. Similarly, suppose here the transmitted symbol is equal to -1 and the noise is equal to minus 0.8. Minus 0.8 means positive noise is added to the signal only. So the positive noise is added to the original transmitted signal. Similarly, so these are the received signals 0.8, 0.2, minus 0.8, 1.9. So this is just example only. And what is the estimated symbol? If the estimated symbol is equal to, if 0 is mapped to +1, the estimated symbol is +1, +1, -1, +1, same as S cap up to here. And in these two cases, the estimated symbol is equal to, transmitted symbol is -1 and the estimated symbol is equal to +1 and the transmitted symbol is -1 and estimated symbol is equal to +1 only. So the bit is 1 and the transmitted symbol is equal to -1 and estimated symbol is equal to +1 only, -1 and +1. So there is a error in these two positions. And after estimating the symbol, So the estimated, it is going to map to the BPSK demapper. So the estimated bit is 0, 0, 1, 0, 0 is transmitted bit and 0 is received at the receiver side, 0, 0, 1, 1, 0, 0, but here 1 and 0. So here 1 and 0 only. So there is a error. The transmitted bit is 1 and the received bit is 0. Transmitted bit is 1 and the received bit is equal to 0 only. So this is the error. How this error is occurred? When symbol -1 was transmitted, the received symbol is like -0.8. The noise was 0.2. For every, suppose for example, so this is the 0 and estimated symbol is equal to, suppose S cap is equal to +1 and left side S cap is equal to -1 only. So this is the threshold. The threshold is equal to 0 is the threshold. There are many received signals. There are many received signals above the threshold and below the threshold only. Suppose, for example, if the received signal is above the threshold or right side of 0, so the decision is when symbol like 1 was transmitted only. Whereas in the received signal is like before the threshold or below the threshold, so the estimated symbol is equal to -1. This is the decision or a threshold. Based on this threshold, so which signal was transmitted and which signal was received. Suppose if it is a positive side and above the threshold, the symbol 1 was transmitted and below the threshold symbol -1 was transmitted only. Suppose here how this error is happened means, so I have considered this received signal. This received signal is close to the 0 only. This received signal is close to 0. Suppose, for example, here R is equal to 0.1. Just assuming, suppose I have considered one received signal above the threshold. All are received signals only. So I have taken one signal. This is close to 0 or close to the threshold. The received signal R is equal to 0.1. R is equal to 0.1 and the transmitted signal is equal to S is equal to 1. So what is the noise here? Noise is equal to -0.9. S is equal to 1 and R equal to 0.1. So what is the noise? Noise is equal to -0.9. Suppose, for example, this is close to 0 means maybe R is equal to 0.1. So the decision is maybe taken a wrong decision. When S is equal to -1 was transmitted. So what is the noise? Noise is equal to 1.1. So this is the received signal close to threshold and R equal to 0.1 and calculate the noise. Noise is equal to -0.9. Suppose this received signal is maybe the decision has taken a wrong decision at the receiver side. The transmitted symbol is equal to -1 is the transmitted symbol and calculate the noise. Noise is equal to 1.1 is the noise. Choice can be erroneous. In those cases, error may be happened because if the received signal is close to the threshold, error may be happened. So the receiver takes a decision sometimes erroneously. So maybe a wrong decision. Sometimes this type of errors are happened at the receiver side only. So that's why S cap is symbol closest to R. So when the optimum decision, the estimated symbol is closest to the received signal. This is one of the example. So maybe this received signal is close to 0. Maybe decision is taken a wrong decision only. Maybe there will be a chance to that side, or there may be a chance to this side only. So this is the how error is happened at the receiver side, means this is the best example and simple example and easy example also. And how to calculate bit error rate and SNRs of AWGN channel using BPSK modulation only. So this is the error rates and SNR. This is the continuous type channel only, or you can take discrete type. Generally, discrete type channels are used in the multi-carrier systems. The bit error rate. Bit error rate means what is meant by bit error rate means suppose we are transmitting 10,000 bits or 1 lakh bits are transmitted from transmitting station to the receiving station only. So the transmit n number of bits, say n is equal to maybe 10,000. And at the receiver side, to receive 10,000 bits, out of 10,000 bits, how many bits are gets error at the receiver side only. So find the number of errors at the receiver side out of 10,000. Suppose, for example, 100 bits are errors at the receiver side out of 10,000. So what is the bit error rate means number of error bits by total number of transmitted bit is called as a bit error rate only. So the bit error rate means calculate the probability. Suppose A is transmitted. A does not equal to A cap. Probability of error means 0 transmitted, 1 is received at the receiver side. 1 is transmitted and 0 is received at the receiver side. There is a error. So to calculate what is the probability of error or probability of bit error, PE or BER is the notations of bit error rate. Calculate the probabilities. So the probability of A does not equal to A cap. A is 0 and A cap is equal to 1 only. Does not equal means the estimated signal is not equal to the transmitted signal, and calculate the error. So what is meant by SNR means signal to noise ratio. These two are very, very important performance metrics in wireless communications. Signal to noise ratio, signal power by noise power. So here noise is AWGN noise only. So the noise power of AWGN channel is equal to N0 by 2. Signal power by noise power. Calculating SNR. How to calculate SNR of different modulation techniques. In different modulation techniques, suppose the simple modulation technique is BPSK modulation. In BPSK modulations, we have two symbols, symbol 1 and symbol 0 only, which is mapped to +1 and -1. So the signal energy is equal to, or a symbol energy is equal to, anyhow, symbol is having only one binary bit. So the symbol energy is equal to mean of square of symbols. How to calculate energy of a symbol means mean of square of symbols. How many symbols in BPSK? 2 symbols. So the square of symbol 1 and square of symbol 2 plus 1 square plus -1 square divided by 2, which is equal to mean of square of symbol is equal to 1 only. So what is the noise power? So the noise power is equal to sigma square in AWGN, and SNR is equal to signal power by noise power. Signal power is 1 and the noise power equal to, suppose they particularly they will give sigma square is equal to like 10 power -9 or whatever value they have given, substitute here and calculate the SNR of BPSK modulation. Similarly, QPSK QAM modulation also this procedure to calculate the SNR of different digital modulation techniques. And BER versus SNR for BPSK over AWGN. So over the AWGN, how the BPSK modulation is used and how to calculate bit error rate and SNR of different modulation techniques over AWGN channel. So here, this is the decision, the threshold. The threshold is equal to 0 threshold, and there are 2 symbols which is mapped to +1 and -1. So the error, if n is greater than 1 and symbol s is equal to -1, actually s is equal to minus from the left side only. But here we have received s is equal to transmitted is 1 and the received at the receiver side is -1. So there is a error. And this side also the transmitted symbol is equal to +1 and n is less than -1 only. So there is a error. How to calculate the bit error rate of BPSK over AWGN means the probability of S is equal to 1. So the symbol +1 was transmitted and the probability of n less than -1 only. +1 means so n greater than 1. But here n less than 1. There are two probabilities. 1 was transmitted and 0 was received. 0 was transmitted and 1 was received. These two are the errors only. So the probability is n is here not +1, -1, and here it is n less than +1 or n greater than -1 only. So what is the probability of here? It is 1/2 is the probability. There are two symbols. The probability is half of the probability of each symbol, and calculate here the probability. And what is the bit error rate of BPSK over AWGN is equal to, so the probability of symbol 1 is in terms of the Q function, so 0.5 times of Q function of SNR only. So RQ function of 1 by sigma square is the probability only. First calculate here BER and SNR equal to signal power by noise power in terms of the Q function, in terms of the error function, to calculate the bit error rate only. And these are the basics of wireless communications, like performance metrics, how to calculate the bit error rate of only digital modulation techniques, and also using the channel, how to calculate the bit error rate, bit error rates and SNRs of normal digital modulation techniques over the AWGN channel. So now index modulation techniques. In index modulation technique is a novel digital modulation scheme with high spectral and energy efficiency. By using this index modulation, how it is increases spectral efficiency, energy efficiency means we are transmitting more data with the help of indices of antennas. Or index bits are also considered. Not only transmitting only the data based on the indices, we are transmitting more data from transmitter to the receiver only. So that's why to increase the spectral efficiency and also increase the energy efficiency by using this index modulation. And especially these modulation, index modulation techniques are used in 5G communications only. 5G wireless communications, almost all waveforms in 5G. The indices of the building blocks of the considered communication systems are used to convey additional information bits. So using the normal modulation techniques, we are transmitting the information bits only. But here, along with additional information bits are transmitted at a time by using this index modulation techniques. So that's why to increase the spectral efficiency. And two promising forms of index modulation techniques. One is under index modulation, the important index modulation technique is spatial modulation technique. Under index modulation, spatial modulation is one of the index spatial modulation technique. And again, under spatial modulation, there are many spatial modulation techniques like enhanced spatial modulation, generalized spatial modulation, and quadrature spatial modulation. I will show you in the further slides for other spatial modulation techniques. So under index modulation, there are many spatial modulation techniques. So what is the concept of this spatial modulation means? The indices of the transmitting antennas of a MIMO system, massive MIMO system, or any other multi-carrier systems. And one of the application of IM is OFDM. IM is one of the index modulation application is OFDM IM. In the OFDM IM, there are many carriers are used in OFDM. All the carriers are used to transmit the data. That is the actual concept using normal digital modulation technique. By using index modulation technique, we are not using all the carriers to transmit the data. Only few carriers are selected and the remaining carriers are in the silent mode. They are not going to transmit any data. Only few carriers are used to transmit the entire data. So the power will be reduced because all carriers are not used means the transmitted power will be reduced. And the same data is transmitted along with additional data bits also. So the spectral efficiency is also increases. There has been a growing interest on index modulation techniques over the past few years, energy efficiency and spectral efficiency. These two are the important performance metrics in wireless communication systems. There are many performance metrics. This is one of the performance metric, energy efficiency and spectral efficiency only. In energy efficiency, what is meant by energy efficiency means is defined as the number of bits transmitted per joule of energy. Actually, first I will read the definition, then mathematically how this energy efficiency is increases. But at the same time, suppose if the spectral efficiency is increases, energy efficiency is increased or decreased, I will show you mathematically. The definition of energy efficiency is number of bits transmitted per joule of energy. How many bits are transmitted? The units of energy efficiency is bits per joule. And spectral efficiency. Spectral efficiency refers to the information rate that can be transmitted over a given channel bandwidth in a specific communication system. So that is equal to bits per symbol for hertz is the units of spectral efficiency. And this is also another type of definition. Spectral efficiency, spectrum efficiency, bandwidth efficiency refers to the information rate that can be transmitted over a given channel bandwidth. Over a given channel bandwidth, how much information rate that can be transmitted over the given channel bandwidth is called as a spectral efficiency. So this is another way of definition. The data rate or throughput upon channel bandwidth only. And here, you know the Shannon's capacity theorem, C is equal to B log base to 1 plus SNR only. Actually, this is called as SNR. Signal power by P is signal power, and N0 B is equal to noise power. AWGN channel noise power spectral density is equal to N0 by 2. N0 by 2 into bandwidth of the channel is equal to 2 omega N0 B. So the N0 B is noise power. Signal power is P and the noise power is sometimes N0 B equal to sigma square also. So P by N0 B is SNR. And what is the spectral efficiency? So this is the SE stands for spectral efficiency. Spectral efficiency is equal to, from this equation, C by B is equal to log base to 1 plus P by N0 B only. So again, this equation can be written as 2 power like log base to 2 power spectral efficiency is equal to 1 plus P by N0 B only. So the spectral efficiency is equal to C by B. or 2 power spectral efficiency minus 1. Again, rewrite this equation. 2 power spectral efficiency minus 1 is multiplied with N naught B is equal to P only, signal power. So the spectral energy, this is the spectral efficiency equation. Spectral efficiency. And energy efficiency is equal to C by P is the energy efficiency. So energy efficiency is, what is C? C is equal to, in this equation, C equal to B into spectral efficiency divided by P is equal to, here P, signal power is equal to 2 power spectral efficiency minus 1 multiplied with N naught B only. Substitute P is equal to here, and numerator is equal to C. C is equal to beta times of spectral efficiency. So this is the spectral efficiency upon N naught 2 power spectral efficiency minus 1 is the formula for calculating energy efficiency. So in this equation, spectral efficiency is increases, actually, which is inversely proportional. Spectral efficiency is increases means energy efficiency is decreases. SC is the spectral efficiency. When the spectral efficiency is increases and energy efficiency is decreases. Suppose if we want to increase the spectral efficiency, we are losing the energy efficiency. So how these both are, there are many like techniques to improve the spectral efficiency, but at the same time, energy efficiency is, we are losing the energy efficiency. If both are, we are not compromising losing the energy efficiency, and but at the same time improve the spectral efficiency, we go for index modulation techniques. Suppose in MIMO and massive MIMO, suppose how to increase the spectral efficiency with mathematically to calculate the energy and spectral efficiency, it is easy to understand. And suppose, for example, one simple MIMO system. For consider a simple MIMO system, 2x2 MIMO. We have transmitter and the receiver. At the transmitter side, we have two transmitting antennas, X1 and X2. At the receiver side, we have two receiving antennas, Y1 and Y2 only. So the first transmitting antenna is transmitted, actually X1 and X2 are transmitted bits, and Y1, Y2 are the receiving antenna has receiving the receiver has receiving the transmitted bits only. Suppose the first antenna is transmitted X1 bit, and the first antenna is transmitted X1, like first antenna is transmitted to symbol X1, and the first antenna is transmitted symbol 1 to the second antenna. First antenna received X1 and second antenna is also received X1, and the second antenna is transmitted, and at the receiver side, two antennas has received at symbol X2 only. So this is H11, 1 and 1, H11. So this is H12, actually this one H12, and H21 and H22, where the received signal equation is Y1 is equal to, actually Y bar is in terms of the vector notation. Here there are two transmitting antennas and two receiving antennas, 2x2 MIMO only. NT and NR stands for transmitting antennas and the receiving antennas only. So what is the received signal? Y1 and Y2 are two received signals, because it is having two receiving antennas only. Y1 is equal to H11 X1 plus Y1 is also received this symbol only, X2 symbol. So H21, H11 and H11, H12, this is 1, 2. H11 X1 plus H12 H12 X2 only, H11, H21. Next one is Y2 is equal to H21 X1 plus H22 X2 and channel noise. Maybe here channel is equal to AWGN channel or in MIMO channel or relay fading channel. So it depends on your assumption. Channel noise is equal to N1 and N2. What is meant by inter-channel interference? So actually using index modulation technique, one of the advantages is to avoid inter-channel interference. So why I am explaining this 2x2 MIMO system means how to occur inter-channel interference. What is meant by inter-channel interference? Suppose there are two received signals, Y1 and Y2. In the vector notation, the received vector is equal to here, Y bar is the received vector, and H11 and H12, actually this is the channel matrix is equal to H, and X1 like X2 or the Y is equal to X, HX plus in terms of the vector notation, Y bar is equal to HX bar plus N bar is the received signal equation only. X bar is the transmitted vector and Y bar is the received vector and N bar is the noise vector and H is channel matrix only. The channel matrix H is equal to H11, H12, H21, H22. It's a 4x4 matrix because two transmitting antennas and the two receiving antennas, the size of H matrix is equal to 2x2 is the size of H matrix only. Like using ML detection, first of all, before that, inter-channel interference. What is meant by inter-channel interference? So here we are using only two transmitting antennas and two receiving antennas only. Suppose when we are increasing massive MIMO or we go for massive MIMO, this is the simple MIMO system. Suppose in the massive MIMO system, in massive MIMO, what are the minimum number of transmitting and receiving antennas means 64 antennas minimum. So before 64, it is equal to normal MIMO system only. From 64 onwards, it's a massive MIMO system. 64 and above that number only. So the number of transmitting antennas are increases. Suppose only two transmitting antennas, the received signal at the receiver side. So the first antenna has received one signal. Y1 is equal to what is the expected signal at the receiver side, first receiving antenna. The expected signal is actually X1 is the expected signal. But at the receiver side, the first receiving antenna not only receiving the X1, but it is also received the X2 signal. So only the expected signal is X1. But other than X1 is also received at the receiver side, first antenna, receiving first antenna. Similarly, suppose in the second antenna, the expected output at the receiver side, the second receiver has received only X2. Actually, the cross lines indicates it's a error only. So Y2 received X2 only, but not only receiving X2, but it also received X1 also. We are considering or a simple example of 2x2 MIMO, only two transmitting antennas and two receiving antennas. The receiver has received not only X1, not only X2, other transmitted signals are also received at the receiver side. Suppose in the massive MIMO, we are increasing number of transmitting antennas are 64. 64 antennas are received means so H11, H12, H13, 14 and so on. How many transmitted signals? 64 transmitted signals are received at the receiver side only. 64 means not the expected signal is X1. other than x1, x2, x3, x4, and so on 64. So that's why the interference is more through this channel only. That's why inter-channel interference. Actually, this is the channel only. So the interference is more. The one signal is affected by the other signal. The actual signal is x1 only. So the x2 is interfere with x1 and x3 is interfere with x1, or so interference is more through the channel only. That's why this is called as inter-channel interference. If the inter-channel interference is more using in normal modulation techniques, using index modulation technique, the inter-carrier interference will be reduces. How to calculate the error? Actually, okay, inter-channel interference is more in normal MIMO system or massive MIMO system. How to reduce this inter-channel interference, and before reducing this ICI, how to calculate the error first of all. At the receiver side, we are using a simple estimation technique or a simple detection technique is ML. Maximum likelihood estimation or maximum likelihood detection is used at the receiver side only. Even in the using index modulation or using normal modulation techniques, the ML detection is simple ML detection is used at the receiver side to estimate the channel, using this estimation technique to estimate the channel characteristics. Suppose error is equal to norm square of, this is the received signal equation, y bar minus h x bar, norm square. So y bar, what is y bar? So what is received? So already we know the received signal. So y bar is noun. What is received, or this is the noun signal only. What is h? H is channel matrix. So channel coefficient is also noun to the channel coefficient. And what is x bar? Transmitted signal is x bar only. So the transmitted signal is x bar. Transmitted means which type of modulation technique is used. So here I am using BPSK modulation. Suppose in BPSK modulation, so the transmitted vector is x bar is the transmitted vector and the received vector is y bar, and channel coefficient is h is the channel coefficient. In BPSK modulation, the transmitted vector is equal to x bar. In BPSK, there are two symbols. Symbol 1, S1 is equal to 1 and S2 is equal to -1. There are two symbols of BPSK modulation. What is the transmitted vector? X bar is equal to, this is the vector notation. One is one transmitted vector and another transmitted vector is equal to maybe -1 and +1. So there are four combinations of transmitted vectors. So x bar is equal to 1, -1 is the transmitted vector. And fourth transmitted vector is 2 symbols, 2 power 2 combinations. So the four transmitted vectors, -1 and -1 transmitted vectors. So how to calculate the error using ML detection, how to calculate the error and how to estimate the, which error is the minimum error. Actually using in ML detection, the formula is at the receiver side, y bar equal to x, h x bar plus n bar. Okay, I will give you equation also. Before that, how to calculate the errors. Using this equation, y bar is noun, the received signal is noun, and the channel coefficient h is also noun, and x bar, suppose x bar is equal to, the transmitted vector is, by using this transmitted vector, x bar equal to 1, 1. So substitute here, calculate error 1. And x bar is equal to -1 and +1. So this vector is substitute here in this equation and calculate second error. So because this is the error equation only, there is a small error. And third vector, transmitted vector, 1 - 1. So error is 3. So just in place of X bar, substitute 1, 1 combination, -1, 1, 1, -1, and -1, -1. Calculate the possible errors are 4 possible errors, E1, E2, E3, and E4. Out of these 4 errors, which error is minimum? So which error is minimum means, say for example, E3 is minimum. Just for example, E3 is a minimum error. What is the corresponding transmitted vector? The corresponding transmitted vector is 1 minus 1 is the transmitted vector only. So at the receiver side, to estimate the transmitted signal is 1 and -1 only. So in the ML decoder or a receiver, so the formula is X cap is equal to argument of minimum X bar norm of Y bar minus H X bar square. So for what transmitted vector, X bar is transmitted vector. For what transmitted vector, the error is minimum. So this is the ML detection rule. So the simple ML detection rule is, for what transmitted vector, the error is minimum. Similarly, here calculating the 4 errors, which error is minimum? So the corresponding transmitted vector in terms of the, this is X cap, estimated signal only. So using this procedure to calculate the errors and calculate the estimated signal only. So now in spatial modulation, actually these are the concepts of how to estimate the signal. Suppose how to inter-channel interferences occurs when we are increasing the transmitting antennas. So how to inter-carrier interferences reduces by using this spatial modulation techniques or index modulation techniques. Spatial modulation SM. Actually, this is initially invented by Meshla et al. And Jagannathan. And this is the strong and well established computators such as VBLAST and space-time coding systems. SM schemes have been regarded as possible candidates for spectral and energy efficiency for next generation of wireless communication systems, or next generation MIMO means massive MIMO, OFDM-IM, and NOMA-IM. So like that only, next generation wireless communication systems. The multiple transmit antennas of MIMO system, especially these spatial modulation techniques, are used in massive MIMO, not only massive MIMO. So all 5G waveforms, these index modulation techniques are used. Under index modulation, spatial modulation is one of the technique. So there are like here, more specifically, there are 2 information carrying units in SM. So in the SM system or a spatial modulation system, there are 2 ways to transmit the information. One is indices of transmit antennas and M-array constellation symbols. So M-array constellation symbols means modulation symbols, and indices of transmitting antennas. Not only transmitting the bits, and additional bits are transmitted, or additional information is transmitted using indices of transmitting antennas. So how it is dividing indices of transmitting antennas and M-array constellation symbols only. So this is one of the index modulation technique, spatial modulation. Spatial modulation. So suppose if you are understand spatial modulation technique, so the remaining all other modulation techniques or index modulation techniques are basic principle is based on this SM only, just slightly modifying. So spatial modulation is very, very important. If you can understand SM, the remaining all other index modulation techniques are easy to understand. So SM uses only one RF chain. What is meant by RF chain means this is maybe a filter or oscillator or like any other, just this is the sometimes it is called as a switch or sometimes it is called as a path only. A radio frequency chain, RF chains. In the spatial modulation uses RF chain. And information bits are divided into two blocks. So already here, two information carrying units in SM. So the entire information bit or a group of or a sequence of information bits are divided into two blocks. One is antenna index selection and second one is modulation symbol selection. Similarly, indices of transmitting antenna, M array constellation. So modulation symbol selection and antenna index selection only. So by using these two ways to transmit the information from transmitter to the receiver only. It reduces the, actually using this SM, it reduces the hardware complexity, actually decoding complexity, hardware complexity. Complexity means number of real multiplications and additions. Suppose for consider MIMO and massive MIMO, to calculate the complexity calculation, it is easy to understand, but time is a limited time. So that's why I'm not covering that complexity calculation. Using SM modulation, it reduces the hardware complexity and also reducing the, suppose in the MIMO system, 2x2 MIMO, 2 transmitting antennas and 2 receiving antennas are used. So both antennas are active at the transmitter side and both antennas are received at the receiving antennas to transmit the data and receiving the data. But using in SM, out of 2 antennas, we are not using 2 transmitting antennas. Suppose we have considered multiple antennas, but we are using only limited antennas only, whether it is a one or more than one, it depends on the index modulation technique only. We are not using all the antennas. That's why hardware complexity is, suppose for example, 4x4 MIMO system. In 4x4 MIMO system, 4 transmitting antennas and 4 receiving antennas. Even by increasing the antennas, the complexity, hardware complexity is increases. By using spatial modulation or index modulation techniques, even using the antennas, but we are not selecting all the antennas to transmit the data. So even the power will be reduced, hardware complexity is reduced, and decoding complexity is also reduces only using spatial modulation. And no interchannel interference. So here interchannel interference is also eliminated by using this SM modulation only. And spectral efficiency of spatial modulation system is given by, actually this is the formula for spectral efficiency. Log base to NT plus log base to M bits per channel use. Bits per channel use. So this is the spectral efficiency. NT is number of transmitting antennas and M is modulation symbol. Suppose if it is 4 QAM, M equal to 4, 8 QAM, M equal to 8. So to calculate the number of transmitting antennas are, suppose 2 transmitting antennas, log base to 2. Note down what is the value. And suppose if it is NT is equal to, for example, NT is equal to 4, log base to 4 plus log base to, suppose for example, it's a M equal to 2, BPSK modulation. Suppose for example, in BPSK, M is equal to 2. So log base to 4 is equal to 2 plus log base to 2 is equal to 1, 3 bits per channel use. So this is bit per channel use means for every symbol transmit 3 bits. That is the meaning. Spectral efficiency eta of SM is equal to number of transmitting antennas are just assuming 4 and the BPSK modulation, suppose if it is 2 or QPSK modulation 4 QAM, 8 QAM, 16 QAM and so on. To calculate the spectral efficiency, it is equal to 3 bits per channel use. 3 bits per channel use means at a time we have to transmit for every symbol transmit 3 bits. So suppose one antenna transmit 3 bits. Out of these 3 bits, like it is divided. What are the antenna index selection bits and what are the modulation symbol selection only. Like this is the basic transceiver block diagram of spatial modulation SM system. This is the incoming bits, bit stream. It is divided into already here antenna index selection and modulation symbol selection. So the antenna index selection is log base to M, and modulation index selection is log base to M, and the antenna index selection is equal to log base to NT number of transmitting antennas. So this is connected to antenna index mapper, and log base to M is connected to a symbol mapper only. So the entire by combination of these two blocks is equal to SM, spatial modulation block only. So here number of transmitting antennas and number of receiving antennas only. So by combining these two bits, selection bits and a symbol mapper bits, both are given to a transmitting antennas. So the number of transmitting antennas are NT transmitting antennas, like N1, N2, N3 and so on, NT transmitting antennas, and NR receiving antennas only. This is the detection part only. Already I have explained ML detector calculate the errors. Before calculating the errors, here in spatial modulation at a time, so actually in the spatial modulation, at a time only one antenna is active, like where I have written, okay. In the spatial modulation, SM employs multiple antennas arrays as the transmitter, but only one single RF chain is used. Single RF chain means there is a like transmission path in between the transmitting antenna to the receiving antenna only. Out of multiple antennas, in the spatial modulation, only one antenna is chosen or only one antenna is active. The remaining NT minus antennas are silent. So once again, I will repeat, on the chosen antenna or out of NT antennas, only one antenna is active and the remaining all other antennas, all other means NT minus antennas remains silent. So suppose say I have 4 transmitted antennas. Suppose I have 4 transmitted antennas. I am using BPSK modulation. So how to calculate the spectral efficiency? Log base to NT plus log base to M. NT is equal to 4 transmitting antennas and BPSK log base to M is equal to 2. Already we have seen what is the spectral efficiency of SM. 3 bits per channel use only. Using that formula, using this formula to calculate the spectral efficiency, 3 bits per channel use only. Suppose each antenna is uniquely represented by 2 bits only, because already we have assuming 4 transmitting antennas, 1, 2, 3 and 4, just assuming I have considered 4 transmitted antennas. Similarly, at the receiver side also 4 transmitted antennas. So, but what is the spectral efficiency here? 3 bits per channel use. What is the meaning of 3 bits per channel use? Means the symbol, for each symbol transmits 3 bits only. For each symbol transmits 3 bits. And M is equal to, there are 2 symbols, S1 and S2. So 2 symbols means 2 power 2 combinations, like 0, 0, 0, 1, 1, 0 and 1, 1. So each antenna is uniquely represented by 2 bits. Suppose I have 1, 0, 1, 1, 1, 0 and 1, 1, 0. So this is the bit stream. And what is the spectral efficiency? For every symbol transmit 3 bits. It is divided into 3 bits. So first 2 bits, actually what is the concept of SM? So the data is divided into, or transmitted bits are divided into antenna index selection and modulation symbol selection only. Antenna index selection and modulation selection only, or constellation of the symbols only. So there are 3 bits. Out of these 3 bits, 2 bits are assigned to antennas like 0, 0, 0, 1, 1, 0, 1, 1, and 1 bit is this bit is dedicated for modulation symbol only. This is for modulation symbol. Suppose for example 1, 0. This is 1, 0. Which antenna? Already we have assigned to a 0, 0, 0, 1, 1, 0, 1, 1 to each antenna, 4 antennas. Initially we have assuming NT equal to 4. So NT equal to 4 and M is equal to BPSK modulation. M is equal to 2 power 2 combinations 0, 0, 0, 1, 1, 0 and 1, 1. So the antenna indices are 0, 0, 0, 1, 1, 0, 1, 1 and 1, 0 is third antenna. So already we have assigned 0, 0, 0, 1, 1, 0, 1, 1 to the corresponding antenna. Not only this order, you can assign first antenna is 1, 1, second antenna is 0, 0. But these 4 combinations are assigned to each antenna. And modulation index bit 2. Antenna indices are 1, 0. So this is the third antenna indices. The third antenna is active. So the third antenna is active. This third antenna is going to transmit symbol 1. So that is the meaning. This only out of these 4 antennas, only 1 antenna is active. So what is that antenna means? Third antenna, because already we have assigned 1, 0 is for third antenna only. So this third antenna is active. This third antenna is going to transmit 1 bit 1 only, or going to transmit 1 from the third antenna. Suppose for example this one 1, 1, 0, 0. At a time only 1 antenna is active. The remaining all antennas are transmit 0 power only. So why the complexity is reducing means we are using the multiple antennas, but we have to select only 1 antenna and transmit the data bit. Suppose 1, 1, 0. 1, 1, 0 means 1, 1 is indices, antenna indices bits. 1, 1 means 4th antenna. So this 4th antenna is active and remaining 1, 2, 3 antennas are silent. This 4th antenna is transmit symbol is equal to 0 symbol only. At the receiver side also only 1 antenna is active. So that antenna is received this bit. Which antenna is active means like any one of the antenna. Actually all the antennas are receiving the receiving bits. Suppose antenna 1 is received same one, antenna 2 is received same one, and calculate the error. So which error is the minimum error? That is mapped to a SMD mapper, and find out what is the output. This is the concept of SM. Actually here I will explain actually spatial constellation of SM is. So this is one of the example. Like here I have taken number of transmitting antennas are 4, and the number of like constellation, like modulation is 4 QAM modulation. M is equal to 4 and NT is equal to 4, and calculate here using this formula NT 4 and M is equal to 4. So what is the efficiency? Based on the efficiency only, it is assigned to M is equal to 4. 4 constellation. This is the 4 QAM modulation constellation diagram for 4 QAM 0, 0, 0, 1, 1, 0 and 1, 1 only. So the spatial constellation 3D diagram is encoding diagram is NT is equal to 4. 4 transmitting antennas 1, 2, 3 and 4. 4 transmitting antennas, or you can write transmitter 0, transmitter 1, transmitter 2, transmitter, or transmitting 1, 2, 3 and 4 also. There are 4 transmitting antennas. and 4QAM modulation technique. The constellation diagram for 4QAM is, this is the constellation diagram 0, 0, 0, 1, 1, 0 and 1, 1. So the transmitted data, this is the procedure for encoding side or transmitter side only. Suppose that data transmission or input bit stream is, this is the input bit stream 1, 1, 1, 0 and 0, 0, 0, 1. This is the stream of bits, input bits. It is divided into there are 4 transmitting antennas. Each transmitting antenna is assigned to 0, 0, 0, 1, 1, 0 and 1, 1 only, because it's a 4. Each antenna is assigned to 0, 0, 0, 1, 1, 0, 1, 1 and M is equal to 4, 4 constellation. It is divided into first 2 bits like 1, 1. So this 1, 1, 1, 1 means from the 4 antennas, already 1, 1 is assigned to 4th transmitting antenna. This 4th transmitting antenna is actually 1, 1. These are the antenna indices bits. Actually, this is the data only. The entire data is transmitted, not only the entire transmitted bits are input transmitted bits are transmitted from transmitter to the receiver. We are not using all the antennas only. Only one antenna. The concept of spatial modulation is at a time only one antenna is active. The remaining all our antennas are like silent, but the entire data is transmitted. So here 1, 1 means the 4th antenna. So already we have assigned to 1, 1 antenna indices bits are 1, 1. Antenna indices means active antenna. So the active antenna is like 4th antenna, and the constellation diagram, from the constellation diagram, suppose 0, 0, 0, 1, 1, 0 and 1, 1 are constellation points. So the inside the bracket indicates, the inside the bracket is 1, 1 here. So the yellow color indicates 1, 0 is 1, 0 means here the data bits are modulation symbol bits are 1, 0. 1, 0 is here. This is 1, 0. And which antenna is active? 4th antenna is active. So inside the 1, 1 means the 4th antenna is transmitted to 1, 0 bits only. So the data is actually 1, 1 is also data and 1, 0 is also data, but only one antenna is active. So that active antenna is the indices bits. Indices means data bits only. And only this antenna is active. This antenna is going to transmit 1, 0 symbols. This symbol. And the remaining all other antennas are like silent mode only. So that's why the complexity is decreases. And one more example, this example is after 1, 1, 1, 0 is over. Next bit stream is 0, 0, 0, 1, 0, 0, 0, 1. 0, 0, 0, 1 means it is divided into 0, 0 bits for 0, 0 means the first antenna. 0, 0 is the indices antenna is, or active antenna is antenna 1. And the data bits are 0, 1 from the constellation. Suppose this is the constellation 0, 0, 0, 1. This yellow color indicates constellation points, or a modulation constellation point is 0, 1. So inside the bracket means antenna, active antenna. 0, 0 means the first antenna is active. This first antenna is going to transmit like 0, 1 bits only. So this is the encoding procedure of SM. But the advantage is at a time only one antenna is active and only one RF chain is used. If how many number of transmitting antennas is active or silent, it depends on RF chains only. So the basic concept of SM is one RF chain is used. One RF chain means only one antenna is active. RF chain means it is a transmission path. That's all. And next one is actually the same thing can be written in the tabular form. The data bits are 0, 0, 0, 1, 1, 0, 1, 1. And the vector notation, the transmitted vector is equal to, this is the symbol. and 0, 0, like 4 antennas. One antenna, first antenna is active. This first antenna is active means the transmitted first antenna means 0, 0 is already assigned. And this S means it's a symbol only, transmitted symbol. Maybe in the BPSK or maybe QAM or QPSK, whatever symbol here. The remaining 3 antennas are silent. This is in the vector notation, transmitted vector notation. And S subset of S means S like having many symbols. Out of all symbols, which symbol is transmitted and which antenna is corresponding antenna is active, and the remaining antennas are off. So here the second antenna is active. The corresponding like 0, 1 is the data bits transmitted, and this antenna is active and remaining all are off state only. So like that, it's a vector notation. And next one is SM mapper. NT is equal to 4 and M is equal to 4 only. Number of transmitting antennas are 4. Transmitting antennas are 4 and 4 QAM modulation. So this is grouped bits like 4 QAM means 2 power 4 combinations, 0 to 16 combinations of data bits, 0, 0, 0 to 1, 1, 1, 1, and the antenna index. So the antenna index is equal to 4 antennas totally, because NT equal to 4. First antenna, 1 indicates first antenna, second antenna, third antenna, fourth antenna only. So this is the lookup table only. Actually using this lookup table to transmit the data. Suppose this is the first antenna. The first antenna is in 4 QAM data symbols. Like the symbol means it's a complex number only, real signal and imaginary signals, so that it can be written as -1 plus 1J. Like the first antenna is active antenna, remaining 3 antennas are like silent. So the first antenna transmitted symbol is equal to plus 1J, -1 plus 1J. So this is X1 and remaining 3 bits 0, 0, 0. So this is the transmitted vector. Suppose here 1. See again the first antenna is active. So what is the transmitted bits? 0, 1. 0, 1 can be written as -1, -1J. Not only this way, you can write in different ways, 16 ways, -1 plus 1J. So some to come look up tables, so like here 1 minus 1J. So we can write 16 combinations of 4 QAM symbols only, real and imaginary terms. So here X1, X2, X3, X4 means X1 is transmitted, the first antenna is active, this is the transmitted symbol, and the remaining antennas are inactive. Suppose here also same. In this case, the second antenna is active, like here too. Second antenna is active. What is the corresponding data symbol? -1 plus 1J, -1 plus 1J. First, third, and fourth antennas are inactive only. So like that, this is the lookup table. And decoding of SM. The receiver of the SM schemes have 2 major tasks. One is active transmit antenna and detection of the data symbol transmitted. Already I have explained like ML detection principle only, how to calculate errors E1, E2, E3. So the same procedure is applied here using in ML detector, and calculate the what transmitted vector is transmitted and like what transmitted vector the error is minimum. So using ML detection at the receiver side to detect the minimum error signal only. So this is the received signal equation, y equal to hx plus n. And so this is assuming the channel matrix is independent, identically distributed, mean equal to 0 and variance is equal to 1. So this is the formula for argument of minimum of norm y minus hx square. And here L and S L cap and S cap are estimated antenna index, and S is modulation symbols only. And what are the advantages of SM? The advantages of SM is simple transceiver design, since only one single transmit antenna is active and single radio frequency chain can be handled the transmission of the SM scheme. And to avoid inter-antenna synchronization. Actually, we are using only one antenna. Out of 4 antennas, at a time, only one antenna is active. There is no, we are not maintaining any synchronization in between the antennas. So that's why inter-antenna synchronization is eliminated, and also inter-channel interference, only one antenna. In the like simple example, already I have considered 2x2 MIMO system. We have 2 receiving antennas only. So 2 received antennas Y1 and Y2. The channel inter-channel interference is arised in that case, but here only one antenna, there is no inter-channel interference, completely eliminating this ICI and IAS also. And high spectral efficiency due to the use of antenna indices as an additional source of information. Using this antenna indices, suppose the data is transmitted using antenna indices, and also only one antenna is transmitted the information only. So the additional source of information is also transmitted. So that's why the spectral efficiency is also more. Simply this is called as higher energy efficiency is also increased. Mathematically, to calculate, it is easy to understand how the spectral efficiency and energy efficiency is more or increased. Disadvantages of SM: the efficiency of SM increases logarithmically, because what is the formula for spectral efficiency of SM? Log base 2 NT plus log base 2 M. So logarithmically increasing the spectral efficiency with eta t, while spectral efficiency of V blast increases linearly with NT only. So this is one of the drawback. And the channel coefficients of different transmit antennas must be sufficiently different SMs, and SM transfers the information using only the spatial domain, and plain SM cannot provide transmit diversity as STC. And so this is the conclusion of this SM only. Then coming to various SM schemes. Actually, under index modulation, spatial modulation is one of the index modulation technique. Under spatial modulation, there are other index modulation techniques are generalized spatial modulation, multiple active spatial modulation, quadrature spatial modulation, and generalized quadrature spatial modulation, and modified generalized quadrature spatial modulation. Almost all spatial modulations like GSM, MASM, QSM, GQSM, MGQSM, the basic principle is SM only. And generalized spatial modulation. In generalized spatial modulation scheme uses multiple RF chains. Multiple RF chains are used. What is the condition for using this multiple RF chains? Means 1 less than or equal to NRF less than or equal to NT. NRF stands for multiple RF chains only. And NT is number of transmitting antennas. Suppose, for example, how many antennas are used, it depends on number of RF chains. How many transmitting antennas are used means it depends upon the number of RF chains. Suppose if the number of RF chains are only 2 in GSM technique. If number of RF chains are 2 means the number of, in the previous example, number of transmitting antennas are 4. Number of RF chains are 2. So what is the active antennas are 2 active antennas. NRF is equal to 1. NRF equal to number of RF chains is equal to 1. based on the above equation. So the GSM, it becomes NRF is equal to 1. Number of transmitting antennas are depends on number of RF chains. Suppose if the number of RF chains is equal to 1, so the GSM scheme becomes spatial modulation only. Because in the spatial modulation, only one SM is used. Sorry, only one transmitting antenna and one RF chain. One less than NRF less than NT. NRF is equal to 1. So the GSM becomes SM. NRF equal to NT. So the GSM becomes spatial multiplexing. Spatial multiplexing only. If the number of RF chains are 2 RF chains are used in SM1 and 2 antennas are active, and the 2 antennas are activated, means in the SM system only one antenna is activated. So only that antenna is transmitted the data. But here 2 RF chains means 2 antennas are active out of 4. 2 antennas are in the silent mode. So these 2 antennas are transmitted the same information. So these 2 different antennas, suppose 1 and the third antenna is active. So the first antenna is transmitted the same transmitted symbol, and the third antenna is also transmitting the same transmitted symbol only. So here in in GSM, here also the advantage is to avoid inter-channel interference, and the spectral efficiency formula is log base to NT NRF. NT is number of transmitting antennas and NRF is equal to number of RF chains. So actually this is NT C NRF. So this is NCR formula, factorial n by factorial n minus R into R factorial. So to calculate how many transmitting antennas, and the number of chains are 2 RF chains. 2 RF chains means definitely 2 antennas are active, and the total how many number of transmitting antennas plus log base to M is the modulation, and calculate the spectral efficiency. So here all activated antennas transmit the same data symbol. Suppose 2 RF chains means 2 antennas active. These 2 active antennas are transmitted the same symbol. So the same data symbol is transmitted from transmitting to the receiving station only. But 2 antennas are active. So this is the difference between SM and GSM only. So compared to GSM is compared to SM, the spectral efficiency is equal to increases to calculate here. So the SM antenna, please unmute yourself. Compared to SM, calculate the efficiency. Same transmitting antenna, same modulation techniques, and calculate the efficiency. Here efficiency is more. And multiple active spatial modulation techniques. So the multiple active spatial modulation technique, what is the difference between this MASM and GSM and SM is actually MASM is extension of GSM only. So extension of generalized spatial modulation, different data symbols are transmitted. What is the difference between previous GSM and previous SM compared to MASM? Here in GSM, 2 antennas are active and transmit the same data symbol. In SM, only 1 antenna is active to transmit the data symbol. But in MASM, different data symbols are transmitted from the selected transmit antennas. Actually, extension of GSM means here the number of transmitting antennas depends on number of RF chains. If the number of RF chains are 3, and the 3 antennas are reactive. These 3 antennas are transmitted different data symbols. Different data symbols means it provides significantly higher spectral efficiency compared to the classical, and the performance wise, this is the intermediate solution in between SM and V blast only. This is the formula for calculating the spectral efficiency. And also 1 minute. Yeah. So the different data symbols are transmitted from the selected transmit antennas to further boost the spectral efficiency. So 2 antennas are reactive, 2 antennas are not transmitted the same data symbol. They are different transmitted symbols. But how to assign the data symbols means the same procedure of SM only. And enhanced SM. This enhanced SM means combinations of constellations are used. So in the previous 3 techniques, SM, GSM, and MASM, using either BPSK or QPSK or QAM modulations only. Using in the enhanced SM, like 2 constellations are used, like BPSK, QPSK, BPSK, QAM, and 4 QAM, and BPSK, 8 QAM, and BPSK, like 1 QPSK and BPSK signal constellations. So this is the transmission vector this is the combination of the transmitter. But the what is the difference means here combinations of modulation constellations are used here and transmit the data. And quadrature spatial modulation. In quadrature spatial modulation, actually this is also extension of spatial modulation only. But quadrature means in this spatial modulation technique, a modification of SM to improve the spectral efficiency while maintaining its advantages such as operation with single RF chain. Here we are using single RF chain and only 1 antenna is active, but that active antenna is transmitted like real and imaginary parts of the complex MRA data symbols are separately transmitted using the SM principle only. So suppose here not only 1 antenna is active, it activates 1 or 2 transmit antennas. 1 antenna is transmit real signal and another antenna is transmit imaginary signal only. So in the last 4 techniques, so we are not separately transmitting the data. Real and imaginary we are not separately transmitted. Just symbol is transmitted. But symbol means it contains real signal and imaginary signal only. Suppose -1 + 1j or 1 - 1j, like that only. 1 is real signal and imaginary, suppose for example -1 + 1j. This is real and this is imaginary only. So the real is transmitted by 1 antenna and imaginary is from another antenna only. That is the difference, or otherwise same as SM only. So the SM principle is used here. Only the difference is real and imaginary parts of the complex MRA data symbols are separately transmitted using SM principle. It activates not only single antenna, 1 or more transmit antenna in every channel use. So that's why 2 times of log base to NT. Actually, what is the efficiency calculation of SM? Log base to NT plus log base to M. So here 2 times of log base to NT. So again, suppose in the previous example, calculate NT equal to 4, M equal to 4. So what is the multiplied with here 2 into 2, 4 plus, suppose for example 2, it's a 6. Compared to SM, the spectral efficiency is more here. And this is the diagram. The transmitted symbols. It is split into real symbols and quadrature symbols. So real and quadrature using a 4 QAM or whatever modulation technique. So the real is connected to SM modulator and imaginary by combining both two and given to a like a transmitter transmitting antennas. Here MIMO channel or Nakagami channel, you can incorporate any channel here. and separately receiving at the receiver side only. So this is the spatial constellation of QSM, quadrature spatial modulation. In the SM, like the constellation diagram is 0, 0, 0, 1, 1, 0, 1, 1. But here the in-phase spatial constellation and quadrature spatial constellation. For every symbol, we have in-phase signal and quadrature phase signal, or real and imaginary signals. So the real in-phase spatial is antenna 1, antenna 2, antenna 3, antenna 4. And imaginary, suppose -1. So the first antenna is active, -1 is transmitted. So maybe in the imaginary, antenna 3 is active, like -1J is transmitted. Just same as SM only, but here definitely more than one antenna is active, because one antenna is transmitted by the real signal and another antenna is transmitted by the imaginary signals only. And one more spatial modulation technique is generalized quadrature spatial modulation. Here multiple stages of QSM. This is extension of QSM only. Multiple stages and grouping of antennas. So here grouping, like 2 antennas for one group. Like this is the generalized QSM modulation. NT transmitting antennas and NR receiving antennas. Grouping of antennas, suppose 1, 2 for one group, like that only. So the grouping of antennas according to QSM principle. Principle is QSM only, but here only difference is in the QSM case, we are not grouping any antennas. One is transmitted real signal and another antenna is used to transmit imaginary signal. But here grouping of antennas according to principle is QSM only. It combines the concept of QSM and spatial modulation, spatial multiplexing to improve the spectral efficiency. This is the efficiency calculation of generalized QSM. And this is the lookup table. Grouping means 2 antennas are, suppose first antenna, second antenna for one group. So like that only, second antenna first or second antenna second, like that only grouping of antennas. And transmit, one antenna is real and another antenna is imaginary. And this is modified generalized spatial modulation, requires multiple RF chains to increase the spectral efficiency. It combines the concept of QSM and MASM and avoid antenna grouping, and active antenna varies from NRF to 2NRF at every time instant. And this is the choice of antenna activation pattern vectors being doubled in MGQSM compared to the GQSM. This is the formula for calculating. Suppose it is understand SM, the remaining all spatial modulation or index spatial modulation techniques are very easy by applying the concept. This is the diagram. Here more number of RF chains are used here. And data symbols, it is split into real and antenna indices. And so this is same as QSM principle only. One RF chain and another RF chains. Like the detection rule is same as already we have discussed. These are the simulation results, like comparisons, SM, QSM and RCQSM, bit error rate, SNR versus bit error rates. This is MGQSM and GQSM. 9 BPCU means like spectral efficiency, data rate. And this is 8 only. So this is also different fading, like using relay fading, uncoded and all uncoded 4 QAM, 8 QAM and 16 QAM. Like 3 different techniques, MASM, GQSM and QSM. So actually this is the application. If time is over, so I will stop here. Actually applications are in any 4G and 5G multiple access techniques. This IM is incorporated. Okay, this is the conclusion. SM systems are actually one of the popular application is OFDM, not only OFDM, IM, MIMO IM, Massive MIMO IM, NOMA IM, and all 5G waveforms, IM is incorporated. Then in place of ML, actually, especially in this topic, what is the research gap means in place of ML estimation, low complexity estimation, there are many estimation techniques are available. In place of ML, you can introduce MMSC, you can introduce adaptive estimation technique or LS estimation technique, and MMSC estimation, zero forcing estimation technique. And in place of that ML detector, you can introduce machine learning and deep learning based like algorithms are also introduced to deep learning based algorithms and normal algorithms to compare the performances. Thank you. Any doubts?
Dear participants, if you have any doubt, please ask. Thank you, madam. Thank you very much.
Thank you, sir. Thank you.
I thank you from the bottom of my heart for taking time from your busy schedule to be the resource person for this FTP, madam. Thank you so much. The session was very informative and enlightening, madam. It helps in developing new insights into the domain of 5G technology.
Yeah.
Surely our participants have learnt valuable things, and after this FTP, they will be able to explain and explore 5G concepts in a better way, madam. Surely. Thank you very much, madam. Thank you. Thank you very much, madam.
Sir. Thank you, sir.
Yes. Dear participants, tomorrow we will meet. Thank you.